Hey, welcome back. Hope you're watching us, and as we continue to provide coverage through the final phase of flight of Crew-2's approach and docking to the International Space Station. That's exactly the phase of flight we're in now, Jesse, is approach and docking. Now, we just described that the Dragon itself is now complete with the rendezvous phase and entered into this new phase. So the Dragon itself is going to be prepared for the next phase of flight with a new set of flight rules that are going to be joint with the control teams over on the International Space Station side. So we're going to check in with Courtney Beasley over in Mission Control Houston to see how the teams over there are preparing for Crew Dragon's arrival. Courtney.
Thanks, Gary. The crew is awake on station now after waking up at 1 a.m. Central Time, so just about 15 minutes ago. After their post-sleep period, which ends at 2:30 a.m. Central, the crew will get right into preparing for Dragon arrival. Victor Glover will be in the station's cupola using special software to track Dragon's approach and make sure it's staying in the expected zones. Once Dragon is docked, Victor Glover will be primed to move right into hatch operations. He will start by opening the large hatch at Node 2 forward, giving him access inside the pressurized mating adapter. The crew will then have to pressurize the vestibule, which is the small space between the hatches on Dragon and the space station. This was exposed to vacuum prior to docking, so the crew will need to fill it with air and make sure its pressure is nearly equal with the atmospheric pressures on Dragon and the station. Glover will use a small valve on the station's hatch to slowly introduce air into the vestibule. Flight controllers here in Houston will monitor pressure and temperature readings inside and verify that everything is leak-free before we get ready to open up the hatches. NASA Flight Director Scott Stover is leading teams here in Mission Control Houston for Dragon's approach and docking today. And to his right is Capcom Kathy Bolt, and she will be communicating directly with the crew aboard the station. Right now, there are 7 astronauts and cosmonauts aboard the station, including Crew-1 astronauts Mike Hopkins, Victor Glover, and Shannon Walker, along with JAXA's Suichi Noguchi. And that crew was recently joined by a crew arriving on the Russian Soyuz, including NASA's Mark Vande Hei and Roscosmos cosmonauts Oleg Novitsky and Pyotr Dubrov. Again, we're excited to get 4 new astronauts aboard this station to bring Expedition 65 up to 11 crew for handover. That's the latest from here in Mission Control Houston. Back to Hawthorne.
All right, thank you, Courtney. Now that we are in this next phase of flight, approach, and docking, we're just about a half an hour away from the start of integrated operations with the teams over there with Courtney in Mission Control Houston. That'll also be the time where the crew aboard Dragon will start donning or putting on their suits.
Yeah, and Courtney did mention that Victor Glover is helping getting the station ready and prepared for Crew-2. I thought that was really cool because he was a part of the Crew-1 crew, and now he gets to get the station ready for Crew-2 to come. So we are waiting for the integrated operations to begin, and so while we wait, we're going to take more of your questions. So, do the astronauts get to carry their personal mobile phones with them on the International Space Station?
Well, coverage is a little spotty in low Earth orbit, but they don't necessarily use mobile phones. They do have tablets, but the tablets are connected by Wi-Fi and are primarily used for looking through procedures that are needed for whatever task they're completing. Especially, it's very useful whenever conducting a maintenance procedure. They have racks on the inside of the space station that sort of make up the walls. There are 4 walls on each of the modules, and they could pull a rack back, and sometimes they have to get into the nooks and crannies to get behind the scenes and start fixing some of the wires. So having a tablet that's mobile, connected to the Wi-Fi is really helpful. But if so in terms of, you know, the mobile device that's really as mobile as you get, there are also a number of laptops on board that provide similar functions. In fact, when we saw that picture that I believe Victor Glover tweeted out when they were watching the coverage and watching Crew-2 launch from the Cape over in Florida, they were watching on a tablet, or rather a laptop.
Yeah. We've got another question here. Why do the astronauts wear a spacesuit when they can take it off later in the flight? Well, they do wear the spacesuit in dynamic phases of the flight, but when they're just coasting, they don't really need it. So during liftoff, and then when they are docking with the space station, they do need to don their suits. But otherwise, it would probably be pretty uncomfortable to wear that the entire time. These suits are custom suits made for each of the astronauts, so they do fit them essentially like a glove, but I'm sure it's much more comfortable outside of the suits. So they do get to doff their suits and relax a little bit.
Yeah, and this next question comes from Space, who's asking, are you carrying any unpressurized cargo on this Dragon? If so, what is it? And then some kind words about the broadcast. So thanks for those who are still tuned in with us and following along. We love answering these questions, so keep sending them in. Use the hashtag LaunchAmerica. There is no unpressurized cargo inside a Crew Dragon. The Cargo Dragon has a similar makeup. Instead of the crew accommodations like seats and the displays, it's just more cargo space for them to deliver stuff. But it uses a very similar structure, and you're able to put unpressurized cargo into that. But really, the reason that you don't want unpressurized cargo in a Crew Dragon is because a Crew Dragon is outfitted with Super Draco engines that would be used for an abort scenario. And the abort, whenever it separates from a Falcon 9 during an ascent stage, takes the trunk with it. You don't want anything to throw off your center of gravity in there. So that's the reason why there's no unpressurized cargo in a Crew Dragon.
Got another question. When do astronauts on the International Space Station go to sleep?
They
or
do
know to go to sleep, specifically. When do they know to go to sleep? I mean, they do have a schedule.
Yeah, they do have a schedule, and at the end of the day, they enter into what's called a pre-sleep period. So before then, they'll usually do some sort of daily debrief to talk about their day, and then also to talk about what's coming up for the next day. But after that, that's when the flight controllers in Mission Control Houston turn off the cameras from the inside, give the astronauts on board some private time, and that's their time to get ready for bed, to brush their teeth, to have whatever meal. If they want to stay up and spend some time looking at the Earth, knowing that they're going into a weekend. Weekends are usually free. They do have a cleaning day designated over the weekend, but otherwise it's available for them to do whatever they want. But that's it's usually after that conference is when they enter into a time where really they can just do whatever they want. They have a lot of flexibility in that time, and it's purposely scheduled that they have at a minimum 8 hours of sleep time.
And I can only imagine that question was asked because of the 16 sunrises and sunsets. Your body probably is not used to that. When the sun goes down, our bodies as humans typically know to go to sleep around that time. So it's probably pretty difficult for 16 sunsets and sunrises.
Well, luckily a lot of the crew quarters in station are they're essentially just telephone booth size pods, you can call them, with a little bit of privacy. Most of them on board, 5 of them actually, do not have windows. On the Russian side, they have windows, and then Mike Hopkins has been sleeping in the Crew Dragon Resilience, and that one has a couple of windows, but they can block it off just to make sure they aren't getting constantly woken up by 16 sunrises. Well, less than that over an 8-hour sleep period, but still a couple of sunrises throughout your sleep cycle would, I think, throw you off a bit. But yeah, they kind of close themselves off from that. Most of their workday.
SpaceX Endeavor for cameras.
Go for SpaceX for cameras.
Hey, can you guys go external for camera, please?
SpaceX copies. Stand by, and we'll let you know when we're external only.
Copy. Thank you.
And just some communications with the core from Crew. They are asking for external cameras only. What that means is they are asking for the internal cameras on the Dragon to be turned off so that they can have a little bit of privacy while they're up there. And so the core is working on that right now.
They're coming up on integrated operations and suit donning very soon. So this is sort of their last moment during this phase of flight. The next phase being the approach and docking phase. Once they put on those suits, they're going to keep them on.
Dragon SpaceX. Cameras are now external.
Copy, thanks.
There you go. That was Corps Arthur Berryalt confirming to the crew that they now have that privacy, because once they do put on those suits, they're going to have to keep them on for the remainder of the flight to dock with the International Space Station. Once they dock, they're going to have the ability to take it off, and then when they enter into the International Space Station, they won't have the suits on anymore. But those suits are critical as an extra safety precaution during the more dynamic phases of flight, docking being one of those phases.
And for those of you just tuning in, you're watching NASA's SpaceX Crew-2 mission, a 6-month rotational mission to the International Space Station. I'm Jesse Anderson, a lead manufacturing engineer here at SpaceX, and I'm joined by NASA's Gary Jordan.
It's great to be here, Jesse. We're just a few hours away from the final approach and docking of Dragon to the International Space Station. The crew is awake. You're hearing some of the comms, and they're ready to monitor the final steps. So let's recap the mission thus far. Launch day preparation started early for our crew members yesterday, the 23rd. About 4 hours prior to launch on Friday, the crew completed their final medical checks before joining the SpaceX team to get into their spacesuits. After suit up in the NASA Operations and Checkout building in Kennedy Space Center in Florida, the crew walked out, waved some final goodbyes to their families and friends waiting outside, and then the next destination for the crew was the launch pad. It was about a 20-minute ride in a Tesla down to pad 39A, where the Falcon 9 and the Crew Dragon spacecraft were waiting for them. About 2.5 hours prior to launch, the crew ingressed or entered into the Crew Dragon spacecraft, walking over the crew access arm, getting a last look out the windows of the Florida Space Coast, and heading into the White Room and then the vehicle. 40 minutes prior to launch, the crew access arm retracted, and then at T-minus 35 minutes before liftoff, the launch escape system was armed, allowing the Crew Dragon to escape the Falcon 9 on the launch pad or upon ascent should there be any anomaly with the vehicle. But it was not needed, as we saw a smooth ride into orbit yesterday, the 23rd, with 35 minutes to go until launch. Propellant loading began, filling the fuel tanks for those 9 Merlin 1D engines, and just 5 minutes before launch, Dragon entered into terminal count, meaning its onboard computers took control of the vehicle.
And at 5:49 a.m. Eastern Time, or 2:49 a.m. Pacific, the 9 Merlin 1D engines ignited and Falcon 9 lifted off from Space Launch Complex 39A, marking the second time humans rode Dragon into orbit. With Falcon 9 first stage at full power, our crew began their journey to the International Space Station. And just after the T+9-minute mark, the first stage landed on the autonomous spaceport drone ship stationed out in the Atlantic Ocean. A couple minutes after that, we had spacecraft separation, where we saw Dragon finally flying free. Our initial orbit after Dragon separated from Falcon 9 was 210 by 190 kilometers, with those values representing the apogee, or the highest point over the Earth, and the perigee, or the lowest point over the Earth. That means that the orbit isn't a perfect circle.
About 47 minutes after liftoff at 3:38 a.m. Pacific, or 10:38 a.m. GMT, Dragon executed the phase burn, the first of 5 major burns required to raise Dragon's orbit and position it for approach to the International Space Station. Dragon raised its orbit using the Draco thrusters over the past day as it chased down the space station. Dragon ended up doing 2 additional phase burn just to fine-tune that approach. They took place at 2:02 p.m. Pacific, or 21:02 GMT, 9:02 p.m. GMT, and 3 p.m. Pacific time, or midnight GMT. The initial phase burn was nominal. That was Dragon's flight computers calculating that it needed additional burns to get positioned for that rendezvous.
And just a few hours ago, the boost burn took place at 6:25 p.m. Pacific time, or 1:25 GMT. The boost burn put our crew in an orbit where Dragon's apogee, or highest point, will be 10 kilometers lower than the station. Then there were just 3 major burns left before we integrated operations in Dragon and will begin Dragon's final approach. Now, after that, we executed the close co-elliptic burn at 7:10 p.m. Pacific time, or 2:10 GMT. The close burn placed Dragon on an orbit roughly co-elliptic with the space station, meaning it was maintaining an orbit roughly 10 kilometers lower than the station the entire way around the Earth. That's in contrast to only being 10 kilometers lower than the station during Dragon's apogee, or the highest point in its orbit, which is achieved by the boost burn.
From there, at 8:34 p.m. Pacific, we executed the fourth major maneuver known as the transfer burn. This is where we raised Dragon's apogee, or the highest point of its orbit, to just 2.5 kilometers lower than the station. Then we rounded out everything with a final co-elliptic burn at 9:20 p.m. Pacific time.
Dragon SpaceX for approach status.
Go ahead, SpaceX.
All right, Megan, just want to let you know that Dragon is now less than 2.5 hours from the earliest docking time. And per your displays, we have a small update for the AI burn time. It's now going to be at approximately 0731. Next, we do have an upcoming out-of-plane burn at 0646. How copy?
Okay, I copy an out of plane at 0646 and a small update to the AI burn. Thanks.
That's a good readback. And last note, following the completion of the out-of-plane burn, we will step into suit donning.
Okay, we copy. We're getting ready for that.
All right, so that interaction there with the core here in Mission Control Hawthorne was confirming the next steps after they completed that final co-elliptic burn. It put them into a rendezvous complete, and that finished that phase of flight. Now they're in approach initiation. So they updated some of the times there for these next couple of milestones, the first set of milestones for the approach initiation phase. That rendezvous complete, or rather the approach initiation, is coming up in 16 minutes. So that's an out-of-plane burn. That'll just do a slight course correction to get us set up for the approach initiation, which moved by just 3 seconds to the right now to midnight, 12:31 p.m. Pacific time. So that is when the approach initiation will send Dragon into the approach ellipsoid. Joint operations set to begin before that. And then, of course, after the approach out of plane burn coming up in 16 minutes, you heard from the core, the suit, the crew rather, will begin donning or putting on their suits, and that'll be in preparation for that approach initiation burn. All right, so that phase of flight was set up to get to where we are right now with these next couple of milestones. This was set up by the final burn in the rendezvous phase of flight called the final co-elliptic burn. That rounded everything out at 9:20 p.m. Pacific time, or 4:20 a.m. GMT, and that just maintained a constant orbit lower than the station, this time just 2.5 kilometers below. It was a shorter burn lasting just over 30 seconds. So now some of these milestones coming up, we're getting into approach initiation, the final stages of Dragon's rendezvous with the space station. This is also where we start integrated operations between the Dragon control teams here in Hawthorne and the space station flight controllers in Mission Control Houston. The teams will transition to integrated operations roughly 45 minutes prior to approach initiation.
During the approach, SpaceX flight controllers will work in tandem with the NASA team in Houston to activate and test out a number of systems on Dragon, including bidirectional communications with the station using the C2V2 system. And C2V2 stands for the Common Communications for Visiting Vehicles, and sets up a data stream from Dragon to the station, giving another path for Dragon telemetry to come to the ground, and giving an additional command capability to astronauts aboard the station. They'll also maneuver Dragon to the proper attitude and initialize the navigation sensors used for the methodical approach to station.
So at approximately 12:30 a.m. Pacific time, or 0730 GMT, Draco thrusters on Dragon will fire for the approach initiation burn when Dragon's about 2.5 kilometers below the station and just 7 kilometers behind it. This will swing Dragon up until it's about a quarter mile, which is around 400 meters directly below the station. This maneuver will also move Dragon inside one of 2 checkpoints around the station that requires a set of go, no-go polls with the different control teams. The first checkpoint is called the approach ellipsoid, or as you might hear it called, the AE. It's an imaginary shape measuring 4 kilometers by 2 kilometers by 2 kilometers, essentially a large 3-dimensional oval. So before Dragon is given permission to move inside the approach ellipsoid, the capsule is configured to be on what is known as a 24-hour safe trajectory. That means that if Dragon lost all control to its thrusters, it would be at least 24 hours before its trajectory would move inside the approach ellipsoid.
Around 1:39 a.m. Pacific time, the NASA and SpaceX teams will do a go-no-go poll to move Dragon inside the keep-out sphere, another checkpoint that consists of an imaginary sphere around station with a radius of 200 meters. Flight controllers use this to monitor all arriving and departing vehicles. This is another chance to confirm all of the guidance, navigation, and control systems are working correctly on Dragon before moving closer to station. It carries a similar requirement on the orbital trajectory that if Dragon were to somehow lose control to all of its thrusters, it and the space station would be safe for 4 orbits or about 6 hours rather than the 24 hours required to enter the approach ellipsoid. Once Dragon arrives at 400 meters below station, it will be at what is known as waypoint 0 and will be the first checkpoint during our approach. The vehicle can hold here at 400 meters, but if all systems check out, it can continue the approach to waypoint 1.
Dragon's move from waypoint 0 to waypoint 1 will swing it up and out in front of the station, arriving at a distance approximately 220 meters. At this point, it will be on what we call the docking axis, which essentially means it's directly in front of the docking port, and the crew are headed to the forwardmost port of the station, the Node 2 forward port. That's where Dragon docked just over a year ago on the Demo 1 mission, also on Demo 2 and Crew-1. It's where one of 2 international docking adapters are located. They were installed for these new commercial spacecraft flights, as well as any other future spacecraft that use the international docking standard.
Once Dragon is only 20 meters away at waypoint 2, the spacecraft focuses on aligning its docking system with the international docking adapter. We may hear the call-out CHOP, or CHOP, which stands for Crew Hands Off Point, a little less than 30 seconds before docking. At this point, any aborts will have to be done automatically by Dragon.
And then the moment we've all been waiting for when our crew arrives at the space station. Dragon will fly in and make contact with the IDA, giving us what we call a soft capture. The soft capture ring then retracts until sensors indicate it's time for 12 hooks to drive into place to give us a hard capture and firmly secure Dragon to its new home on the space station. The station crew, namely Victor Glover, will manually pressurize the vestibule or the area between the Dragon hatch and the station hatch. Meanwhile, umbilicals that provide power and audio and data connections from the station to Dragon are put in place. Then it's time for leak checks and hatch opening, which is currently timelined to come about 2 hours following docking.
Now we can see Dragon has a busy morning ahead, but even in space, it still takes 2 to tango. The International Space Station is also a factor in the mix for this dance-like approach operation. So let's head over to Mission Control Houston for an update from NASA's Courtney Beasley.
Thanks, Jesse. The crew started waking up at 1 o'clock a.m. about 40 minutes ago, and they are currently in a post-sleep period. After their post-sleep period, which ends around 2:30 a.m. Central Time, the crew will get right into preparing for Dragon's arrival. Victor Glover will be in the station's cupola, using special software to track Dragon's approach and make sure it's staying in the expected zones. Once Dragon is docked, Victor Glover will be primed to move right into hatch operations. He will start by opening the large hatch at the Node 2 forward, giving him access inside the pressurized mating adapter. The crew will then have to pressurize the vestibule, which is the small space between the hatches on Dragon and the space station. This was exposed to vacuum prior to docking, so the crew will need to fill it with air and make sure its pressure is nearly equal with the atmospheric pressures on Dragon and the station. Glover will use a small valve on the station's hatch to slowly introduce air into the vestibule. Flight controllers here in Houston will monitor the pressure and temperature readings inside and verify that everything is leak-free before we get ready to open up the hatches. NASA Flight Director Scott Stover is leading teams here in Mission Control Houston for Dragon's approach and docking today. And to his right is Capcom Kathy Bolt. She'll be communicating directly with the crew aboard the station. Right now, there are 7 astronauts and cosmonauts aboard the station, including Crew-1 astronauts Mike Hopkins, Victor Glover and Shannon Walker, along with JAXA's Soichi Noguchi. And they were recently joined by a crew arriving on the Russian Soyuz, including NASA's Mark Vande Hei and Roscosmos cosmonauts Oleg Novitsky and Pyotr Dubrov. Again, we're excited to get these 4 new astronauts aboard the International Space Station to bring Expedition 65 up to 11 crew for handover. That's the latest from here in Mission Control Houston. Back over to Hawthorne.
Thanks, Courtney. Now let's learn a little more about our crew members. Crew Dragon Commander Shane Kimbrough will be making his 3rd trip to space. He was born in Killeen, Texas, and raised in Atlanta. He was selected as an astronaut in 2004. Kimbrough is a retired U.S. Army colonel and holds degrees in aerospace engineering and operations research. He first launched aboard the Space Shuttle Endeavour on STS-126 and then aboard a Russian Soyuz spacecraft for Expedition 49 and 50. Kimbrough has spent a total of 189 days in space and performed 6 spacewalks.
Pilot Megan MacArthur is enjoying her 2nd trip to space, but her first one to the International Space Station. She was born in Honolulu, but considers California her home state. NASA selected MacArthur as an astronaut in 2000, and she holds degrees in aerospace engineering and oceanography. MacArthur served as a mission specialist aboard Space Shuttle Atlantis on STS-125, the final servicing mission of the Hubble Space Telescope in 2009. She operated the shuttle's robotic arm over the course of 12 days and 21 hours, capturing the telescope and maneuvering the crew members throughout the 5 spacewalks to upgrade the Hubble's science instruments, along with removal and replacement of other components to lengthen the telescope's life. Hubble continues to operate to this day, providing scientists the opportunity to make more and more deep space discoveries.
Mission specialist Aki Hoshide is suiting up for his 3rd space flight today. Born in Tokyo, Hoshide was selected as an astronaut in 1999 by the National Space Development Agency of Japan, known today as JAXA. Hoshide earned degrees in aerospace engineering and mechanical engineering. He flew on STS-124 aboard the Space Shuttle Discovery to deliver and install Japan's science laboratory, Kibo. He also flew aboard the Russian Soyuz on Expeditions 32 and 33 for a 124-day visit to the space station. In 2004, he also served as commander of the 18th NASA Extreme Environment Mission Operation, which is an underwater expedition at the National Oceanic and Atmospheric Administration's Aquarius habitat off of Florida's coast, Key Largo coast.
Mission specialist Thomas Pesquet will be making his 2nd trip to space. Born in Rouen, France, Pesquet was selected by ESA as an astronaut in 2009. He has a degree in spacecraft design and control and more than 2,300 flight hours as a commercial airline pilot. Pesquet first flew to space on the Soyuz as a flight engineer for Expeditions 50 and 51, and in that time he worked on more than 50 experiments and performed 2 spacewalks to maintain the space station. He's logged 197 days in space. Pesquet will be the first European to fly in the Crew Dragon and the first time a European has launched from America in more than a decade. All right, so we're coming up on the approach out-of-plane burn. So this burn will be designated to get Dragon lined up for the next major burn, which is the approach initiation burn. We're coming up on integrated operations with Mission Control Houston, a whole new set of flight rules, and then once we execute that burn, the approach initiation, that's coming up at about 12:31 a.m. tomorrow morning. That burn will put us into the approach ellipsoid and set us up for a series of waypoints that'll get us closer and closer to docking with the International Space Station. So some of those waypoints that when we actually execute the approach initiation burn will be waypoint 0. Now, we're doing a course correction before we get to the approach initiation. It's called an out-of-plane, and it helps us to set up for the approach initiation. Now, to make sure we're maintaining a good trajectory through the waypoints, waypoint 0 needs to be 400 meters or about a quarter mile directly below the station. There is an option after the approach initiation to do a mid-course maneuver. Same deal if the approach initiation were to make us slightly off on our trajectory to get through the waypoints. The mid-course maneuver can set us us up right on the right path to make sure we're passing through those waypoints. There's waypoints 0, 1, and 2. 0 is directly below the station. 1 is directly in front of the station, about 220 meters away.
Dragon SpaceX for 144 bidirectional link.
Go ahead.
All right, Shane, just for awareness, right when the OOP burn completes, we will step into comm checks on the big loop, so we can do that in parallel as we start the suit donning procedure. How copy?
Copy all. Thanks.
All right, so some of the communications you heard, we're expecting some comm checks after the approach initiation, or approach out of plane burn, rather. That sets us up on a trajectory to line up with right where we need to be for the approach initiation. So the approach out of plane burn is coming up in just about a minute. So we'll stand by and watch some of the thrusters. It's going to be a very short firing to line us up for that approach initiation burn. So we'll just stand by for that. After the approach initiation, there's a lot of milestones that the crew themselves need to get situated in, including some communications checks with a bidirectional link with the International Space Station. So we'll hear from the station side as well. That'll be really cool to hear astronauts on 2 different spacecraft communicating with each other and with operators on the ground. They'll do those communication checks. They'll put on their suits. They'll don their suits because that approach initiation burn is going to take them into a very dynamic phase of flight. So we're coming up on the approach out of plane burn here soon. We'll stand by to check on the performance of that burn. Burn start.
Dragon SpaceX, that was a nominal out-of-plane burn.
Copy, nominal burn.
All right, Shane, and you are go to begin the suit donning procedure 4.010. Cameras are still external only. Also, when possible, please change your push-to-talk destination for the cabin mic to ISS and initiate a comm check on the big loop with SpaceX, Houston, and station.
Copy, that's in work. SpaceX, Houston, and station. This is Endeavor on the big loop. How do you copy?
SpaceX has you loud and clear.
Houston has you loud and clear.
Maybe the same, SpaceX.
And Endeavor, this is station. You're loud and clear.
Station, great to hear you. We'll be there soon. Loud and clear.
We'll be expecting you.
Some good words from the core to the crew.
SpaceX Endeavor, we're back on Dragon to ground. Hopefully that's where you want us.
Sounds good, Dragon. I will let you know if I need you to transition to big loop before your suits are donned.
Again, again, some good words from the Corps to the crew. They did confirm a nominal OOP burn, or out of plane burn, as well as confirm that they can, the crew can start donning their suits in preparation for the approach phase of the mission.
Yeah, and so that out of plane burn sets us up. It was just a course correction maneuver to make sure we were right in line for the approach initiation burn. That seemed to go very well, so we're right on track. That approach initiation expected to happen at 12:31 a.m. Pacific time, so it sets us right on course. The big loop is a communications channel, as you heard from the various control teams that include both the control teams here in Hawthorne. That was Arthur Berrialt, the Corps Crew Operations Resource Engineer. That was his voice, and you're hearing his voice as well on Dragon to Ground over in Mission Control Hawthorne. That was the Capcom Kathy Bolt responding that Mission Control Houston is looped in and hearing the communications there. And then on board the International Space Station, the voice you heard was JAXA, or Japan Aerospace Exploration Agency astronaut Soichi Noguchi, confirming that they, the International Space Station, are hearing the Crew Dragon crew. The first communication we heard between the two spacecraft. They'll get to chat on the big loop throughout the operations as we enter into joint operations. So that communications channel is set up. We're getting ready and closer for this next major phase of Dragon's approach and docking to the station.
We do have another cool view. Looks like a sunrise coming up here on your screen. Again, the International Space Station does get to see 16 sunrises and sunsets. We're coming on another one, so got the sun bright in that view from the vantage point of the International Space Station.
Yeah, it seems like it wasn't too long ago that we actually saw a sunrise, and here we are again. So the station right now is 262 statute miles over the Atlantic Ocean. It's entering into an orbital sunrise, and the station is the Crew Dragon rather is right behind it, catching up as we enter into this new phase of flight. So while the crew is getting into their suits and preparing for the next major burn, which is the approach initiation burn, we're going to take a short break, let you enjoy some of these views that are coming from the International Space Station, but we're not going anywhere. We'll continue to provide constant coverage until Dragon docks to the International Space Station and we see the crew inside the orbiting complex. Stay with us. All right, we're still enjoying some of the views from the International Space Station, looking at Crew-2 as it continues to make its approach. It successfully performed an approach out-of-plane burn to set it up for the next major burn, approach initiation. And so we're just in the process of the astronauts getting suited up and ready for that burn. We're just about under 2.5 hours from docking, and the crew is getting ready to get back into their spacesuits for rendezvous and docking. Now, the integrated operations have begun, and SpaceX flight controllers closely coordinate each maneuver with the NASA flight teams in Houston. Ground controllers initiate and monitor preparations for approach, including establishing communications with the station and initializing the spacecraft's navigation sensors to prepare for autonomous docking.
We are also just a few minutes away from getting the go ahead for approach. During the approach, SpaceX flight controllers will work in tandem with the NASA team in Houston to activate and test
Dragon, SpaceX on the big loop. Ground is go for approach initiation, and we will be enabling the maneuver shortly. The expected maneuver start time is 0731.
Copy 0731. And copy on the big loop 0731.
And what great timing. We just got the go-ahead for approach. So during the approach, SpaceX flight controllers will work in tandem with the NASA team in Houston to activate and test out a number of systems on Dragon, including bidirectional communications with the station using the C2V2 system. And C2V2 stands for Common Communications for Visiting Vehicles, and sets up a data stream from Dragon to the station, giving another path for Dragon telemetry to come to the ground and giving an additional command capability to astronauts aboard the station. They'll also maneuver Dragon to the proper attitude and initialize the navigation sensors used for the methodical approach to station. So while we wait for the approach, we will continue to answer your questions. Keep them coming in using the hashtag #LaunchAmerica. And we have a question here. Why does the nose cone open?
Great question. One of the primary reasons up front is it reveals 4 Draco thrusters. There are 16 all around Dragon, 12 on sort of the base, the service section Dracos, and then there's 4 on the forward bulkhead. So opening up the nose cone will expose those forward bulkhead Dracos, and they were just used to complete the rendezvous phase. Now we're in the next phase, approach and docking. So with the nose cone open, it allowed those thrusters to fire. It also exposes the docking mechanism. So the Dragon itself, you will see actually on some of the cameras from the space station, when it makes its approach to the station and docks to it, it'll be right where that nose cone has been closed. And that nose cone, when that nose cone closes, it actually protects those components, the docking ring and the service section Dracos, upon re-entry.
Yeah, and it also exposes the guidance and navigation controls, or GNC, that allows Dragon to autonomously fly to the International Space Station. And so that nose cone is actually there solely to protect all of those components during ascent. But once we're in the vacuum of space, we no longer need that type of protection, so we do open up that nose cone. Now, on Cargo Dragon, previously on the first one prior to Dragon 2, we actually used to jettison the cone because we didn't need it anymore. But on these new Dragons, we do keep the nose cone attached, which will help us with making refurbishment a lot faster since we don't need to replace it.
That's right. All right, we have questions coming in. Keep sending them using hashtag #LaunchAmerica. This next one is, are the seats custom made for them or no? And the answer is yes.
Yes, they are.
So yeah, we said Megan MacArthur, will take for example, is sitting in the same seat in the same capsule that her husband Bob Behnken sat in during the Demo 2 mission last year. But it's not exactly the same seat because they switched the molding so it is custom fit to her. Not just the seats, though. The suits themselves are also custom fit and tailored to each astronaut. The helmets themselves are 3D printed. The gloves are matched to the exact specifications of each of the astronauts' hands. So it's a very custom. It's a very custom design, and there is a purpose to it. It's so the astronauts can maneuver or can use their fingers and enable the touchscreen and sensors with the gloves, and they're very comfortable. That's one of the main things. Also, that there's a nice tight seal, and also enables them to, whenever they're form-fitted to the seats, to take the loads that happen during the dynamic phases of flight, including launch. From second stage separation, there's about 4.5 Gs that are taken on the astronauts, and then, of course, the dynamic loads taken during reentry and splashdown as well.
We have another question here. How much room do the 4 astronauts actually have in the Dragon capsule to move about? Well, the inside of the Dragon capsule is approximately 328 cubic feet. And when we showed the views of the crew inside of Crew Dragon, you kind of get an idea of how big that room really is. The 328 cubic feet is pretty spacious for a spacecraft. So they do have a lot of room to be able to float around. It's not as large as the International Space Station, but it is enough to keep them, allowing them enough space to maneuver throughout, long duration flights like this. This is a 24-hour, just under 24-hour flight for the crew.
Another key thing to think about is in space, if you're thinking about a room that is about 328 cubic feet, you don't necessarily get to use the entire space that is the 328 feet. You don't get to use the walls and the ceiling as much. But when you're in space, there is no up, there is no down, so you can strap yourself to a wall, you can turn upside down and start working in a different orientation. So 328 feet should feel a lot bigger. In fact, when astronauts get to the International Space Station, they work on some of the mock-ups that are on the ground, which of course you have to work in the one gravity environment, and then when they go to space, they realize, this is bigger than I thought, because I have a lot more orientations I can maneuver to.
We have another question here. Do they have champagne on the ISS to celebrate the new dock?
Wouldn't that be nice? Wouldn't that be nice? Yeah. No, they'll have beverages like water and tea and coffee, and they do have mixed pouches. The pouches themselves are filled with powder, and they have a variety of different beverages that they can consume on board. A lot of them are selected ahead of time. There's a menu that they can choose from down on the ground here at the food lab at the Johnson Space Center. Gives them some options. They have different flavored drinks. I think most of them end up just drinking water, but having a little bit of variety here and there is always nice. So yeah, maybe some celebratory coffee at the end of the day, maybe just to wind down, but no champagne.
Got another question. Is the International Space Station able to see airplanes flying on Earth from space? I've always wondered this too. It is close enough to Earth to see, the clouds and stuff. So are you able to see airplanes as they pass by?
Yeah, I don't recall astronauts ever saying that they can spot airplanes. It is, think about 250 miles above the Earth. Whenever you look at the Earth's horizon, you can see about 2,000 miles in any given direction. So it doesn't really sound like a lot. In fact, if you look at the whole globe and you draw a circle of 2,000-mile radius around where the space station is, you realize, they actually can't really see that much of the Earth. So you think they're close enough to see a lot of the features. But the Earth is bigger than you think. And so even when they use some of the lenses, some of the camera lenses to take photos, and they're very large lenses able to zoom in very, very close, you can only capture like whole cities at a time. A lot of astronauts particularly take pictures of Houston. That's where the NASA astronauts all live, in Houston, Texas, and really you can capture the whole city, so planes would be super, super small. They can see storms, they can see large cities, but planes, I think, will be just too small enough that you wouldn't be able to actually see them flying in space, or in the air.
But something that they can see, as Shane Kimbrough mentioned earlier in the live broadcast shortly after Dragon separated from the second stage, was they were able to see the second stage that they flew on.
That's right.
So I think that was a very unique moment in time where they got that opportunity. So probably doesn't happen too often, but at least they could see a rocket in space.
That's true. It was a lot closer to them, though. All right, we have another question from Riley. This one is how much personal items are they allowed to bring on their mission? Really just a small bag. Space and cargo on the Crew Dragon is very limited. A lot of it has dedicated to scientific experiments. There's also some emergency equipment in there, so you have some already allocated space on as a baseline for any mission. But each of them do get a small allotment of personal items, and I find that one of the more common personal items that astronauts tend to bring are photos of their family. When they get up to orbit, each will get a designated sleep station. It's just a small telephone booth-sized crew quarters, but they get to decorate it however they want. So just as you would at home, having picture frames of different family members, they get to do so in their crew quarters.
Got another question here. Would an average Joe like me black out at launch with no physical training?
That's a very good question. So the loads you take at maximum on launch are about 4.5 Gs. It is an instantaneous load. It's not a continuous 4.5 Gs. So I think blackouts occur maybe about 8, 9, maybe higher than 9 Gs. But really training for an astronaut is really to condition them for the long duration stay and to mitigate any health effects of being in low Earth orbit. Just in the microgravity environment, when it's interesting. Your brain is the ultimate, or your body, the human body is the ultimate efficiency machine. So if your body's not taking loads, just Jesse, you and I standing here, we're taking loads. We're taking a full one gravity, the whole Earth's gravity on us, pulling down on us. And so we have our muscles and our bones pushing up against the ground to help us to stand up. But when in space, when you don't have that, your body says, hey, I don't need to spend as much energy maintaining my muscle mass and my bone density because I don't have any loads on it. So I'm going to start putting that energy into storage. And so you start to lose your energy and your muscle and bone mass. So they work out on the ground. And then when they go up to space, they continue that workout using a lot of resistive and aerobic exercise to maintain that muscle mass. That physical fitness is absolutely key to maintaining those elements of the body throughout their flight, so that then when they return to Earth and they start reconditioning, they can get right back to the gym. In fact, I actually got a chance to talk with Shane Kimbrough when he came back from his first flight. On day 2, after he landed in Kazakhstan, he flew back to Houston. The very next day, he was in the gym.
Oh, wow.
Yeah, he was. So they recondition very, very fast, and it's all due to the conditioning they need to do to get prepared for flight.
Got another question here. What is the black cylinder at the back of the vehicle? Is it part of the crew module or is it for fuel? And I think this is referencing the solar panels on the trunk of the Crew Dragon. That is exactly what it is. It's the solar panels to provide energy for the vehicle as it is out in space. Basically, this is how it replenishes the energy that it needs. Yeah.
That's it. Yeah, and on the underside of that, we got a little bit of a peek when the spacecraft itself separated from the second stage. We were able to look right underneath it. It's sort of hollow on the inside of the trunk. It's an open trunk and it's unpressurized. There is a variation of the Crew Dragon that is a cargo version, and it's modified. It doesn't have the crew accommodations like the environmental control life support systems. It doesn't have the seats. It doesn't have the display panels, and it just maximizes the total available volume for cargo, for stuff to go up to the station. Some of it is powered lockers to maintain certain temperatures on the way up. But on the cargo version, they can use that empty space in the trunk to put unpressurized cargo. just on the most recent cargo mission, they brought up a whole new module for the space station, an airlock. It's a commercial airlock built by NanoRacks and has the ability to deploy satellites. It can host payloads, but that whole airlock, that whole module was able to fit in the unpressurized trunk. Coming up this summer, there's going to be new solar arrays in the unpressurized trunk underneath that section for the cargo variation, and those solar arrays will augment the power supply being drawn from the sun, so station operations can continue in the future. Yeah, here's a graphic of the Dragon, so you understand the scale. 27 feet tall, and you can see the black part on the trunk section that is at the bottom of your screen. That's what Jesse was describing. Those are the solar arrays, and they draw power and provide it for Dragon's flight to the International Space Station. Once it docks to the space station, you see at the very top of your screen, sort of that slanted line towards the upper cone is the nose cone. Once that opens and is deployed, it docks to the International Space Station, and an umbilical is attached, providing data and power and communications between the Dragon and the International Space Station. So it no longer needs to draw power using the solar arrays on Dragon throughout its 6-month stay on station. It can just kind of draw power through that umbilical.
We've got another social question. What time zone will they follow in space? And that's a really good question because, you know, every a few miles on Earth, it's a different time zone. But the International Space Station is flying around the Earth multiple times a day. So what time zone do they use?
It's a very good question. We chose Greenwich Mean Time. So it is an international space station. You have 15 partner nations. You have mission control support centers all across the globe. You have them in Houston, Texas. You have them in Russia, in Moscow. You also have stations in Japan, in Canada. You have some in Germany. So where do you put time where everybody can agree on? You pick right in the middle. So Greenwich Mean Time is what they operate. In fact, when we are providing some of our times for some of the major milestones, we're saying Pacific time. Jesse and I are in Hawthorne, California with SpaceX flight controllers here in Mission Control Hawthorne, but Greenwich Mean Time being the time that the station astronauts are operating on. So that's the time they follow. And in fact, they actually shifted, the astronauts did, the Crew-2 astronauts, they shifted their schedule to support, to be able to go right into daily life in Greenwich Mean Time on board station.
SpaceX Endeavour comm check from PLT suited.
SpaceX has you loud and clear, Megan. This is your suited comm check.
Copy, thanks. We're going to disconnect the cabin mic.
SpaceX copies.
And what you're looking at on your screen is an even better view of Crew Dragon from the International Space Station. So much so that you can actually see the open nose cone on Dragon there. This is giving us good signs that we are getting very close to docking, just a couple hours away from docking with the International Space Station on this Crew-2 mission.
Yeah, so this view now, you're looking at the station cameras that are looking at Dragon. The orientation from the cameras is sort of upside down. That nose cone looks like it's coming downwards, but the view itself is upside down. So when you see it come up and swing in front of the station, the nose cone will actually be flipping up towards the zenith or towards the space-facing side of the International Space Station. All right, so as we continue to get great views from the International Space Station of the Crew Dragon, we're now in the approach phase for Crew Dragon, completing an out-of-plane burn to align us up with the next major burn at approximately 12:31 a.m. Pacific, or 0731 GMT. Draco thrusters on Dragon will fire for the approach initiation burn when Dragon is about 2.5 kilometers below the station and just about 7 kilometers behind it. That'll swing Dragon up until it's about 400 meters, or about a quarter mile directly below the station.
This maneuver will also move Dragon inside of one of 2 checkpoints around the station that requires a set of go-no-go pulls with the different control teams. The first checkpoint is called the approach ellipsoid, or as you might have heard it called, the AE. It's an imaginary shape measuring 4 by 2 by 2 kilometers, essentially a large 3-dimensional oval. And before Dragon is given permission to move inside the approach ellipsoid, the capsule is configured to be on what is known as a 24-hour safe trajectory. This means that if Dragon lost all control to its thrusters, it would be at least 24 hours before its trajectory would move inside of the approach ellipsoid.
So while we wait for that approach initiation burn, let's check in with Courtney Beasley in Houston. Courtney.
Thanks, Gary. The crew is awake aboard the station after waking up a little over an hour ago at 1 a.m. Central Time after their post-sleep period, which ends in about 10 minutes at 2:30 a.m. Central Time. The crew will get right into preparing for Dragon arrival. NASA Flight Director Scott Stover is leading teams here in mission control for Dragon's approach and docking today. We just heard around 2 a.m. over the loops that the International Space Station's solar arrays are feathered. So about 3 hours prior to docking, teams began to feather the International Space Station's solar arrays, which is a multi-step process that is spaced out until Dragon is on the docking axis. The first part of the process is when both solar array rotary joints are parked and locked, and then the beta gimbal assemblies are parked, with 2 being latched while the 4 other beta gimbal assemblies continue to track the sun. Both systems are typically used for the solar arrays to continuously track the sun so they get optimal energy generation aboard the station. So again, all of this work to feather the arrays is to protect the arrays when another spacecraft is flying in proximity to the station. The teams on the ground in Mission Control Houston and the systems on the station all remain a go to receive Dragon in a couple of hours. That's the latest from here in Mission Control Houston. Back to you guys at Hawthorne.
Thanks, Courtney. Now, while we wait for the Dragon to fire the approach initiation burn, which should be happening in around 10 minutes from now, let's answer more of your questions. We have another question here. What was the zero-G gravity indicator for this flight? And hello to the Netherlands. Well, we did see, we were watching earlier and waiting for that zero-G. We did get to see it when the crew gave us a tour, and it is a penguin that they named Gwyn.
I love it. The penguin itself was chosen by the kids of the astronauts themselves, Crew-2. They got together, they got to pick and even name the zero-G indicator, and so we got a little bit of a sneak peek of that. Gwyn. Yeah, definitely. And they're calling Gwyn the 5th crew member aboard Crew Dragon Endeavour.
Yeah, I love this tradition where each crew gets to kind of pick their zero-G gravity indicator. Yeah. And they get to name it and pick as a team, and the crew really becomes a family. So it's really cool that they came together and allowed their kids to actually pick this one.
Yeah. Definitely a bonding experience. They're going to be spending a lot of time on station, so they get together as a crew and they bond. And we've actually seen it in a lot of their pre-flight activities and some of the things they've been doing, some of the photos they've been sharing that they got to be together as a crew. They seem to have a very tight connection. In fact, at L-1, the day before they launched, they went to the beach together, put out some blankets, they threw up the Crew-2, just enjoying the Earth while they had that last day on Earth, because for the next 6 months, they're going to be in space.
Got another question here. What happens to the second stage after SECO? And SECO is second engine cutoff. And I think they mean after second stage's mission is complete, it will separate from Dragon and then be deorbited and basically break up in the Earth's atmosphere so that there is no space debris.
That's right. As the crew were getting situated, after they were put into orbit by the second stage and separated from the spacecraft, they were getting ready and unbuckled to take their suits off. And they mentioned that Thomas Pesquet, while he was up, took a glance out the window and was actually able to see the second stage trailing in the same orbit as them. So they all mentioned they rushed to the window to go get glimpses of the second stage. It was following them for a bit before it slowly gets dragged in for re-entry into Earth's atmosphere.
Yeah, that must have been an incredible view.
Absolutely.
I mean, it's probably not very often that you get to see a rocket from a rocket.
That's right.
We've got another question. Why do you jettison the trunk, the trunk on re-entry? Do you reuse the trunk, or do you let it burn up in the atmosphere?
Yeah, the trunk does its job on the way up to the International Space Station. Jesse, you described a little earlier that on the trunk, part of the reason that they have it is there's a series of solar arrays that are able to draw power and provide power on Dragon's ride uphill. So that provides the power up until it docks to the International Space Station, and then it uses a space station's power while it's there for 6 months. Then when it's time to undock, it provides power on the way downhill, but right before it re-enters the Earth's atmosphere, it must jettison the trunk because the trunk is blocking a very important segment of the station, the heat shield. And that heat shield is absolutely necessary to go through the thicker atmosphere and take the heat upon re-entry before you're able to deploy those parachutes.
Yeah, and by that time, the trunk has done its job, so we no longer need it for that portion of the final splashdown. We've got another question. Who maneuvers the cameras that are used to monitor the Dragon's approach from the ISS?
All right, that's right. And in fact, this is the view that you're looking at on your screen. That is a camera that is controlled by a flight controller in Mission Control Houston. That
Dragon SpaceX comm check on Dragon to ground.
Endeavour has you loud and clear, Dragon to ground.
SpaceX copies and has you the same, thanks. We just had a brief pause in TDRS return due to vehicle geometry, but we have you back loud and clear.
Yeah, and the TDRS mentioned during this call is the tracking.
Copy that. And SpaceX,
right.
We've had all 4 of us in our seats, and you are welcome back on board with cameras.
SpaceX copies. All 4 crew members are suited, and we are coming back on board with internal cameras. Can you also confirm good intercom checks between all 4 crew?
Affirm, good intercom checks, all 4 crew.
SpaceX copies all. Thank you. We will step into suit leak checks following the approach initiation.
Endeavour copies.
All right, so that interaction there was the crew or the ground operation ground controllers here in the or flight controllers rather in Mission Control Hawthorne. Just checking in on the crew. There's going to be handovers between the tracking and data relay satellites. They're geosynchronous satellites that are way above where they are. That's about 23,000 miles above the Earth. Where they are is about just approximately coming up on 250 miles. But we were talking about some of the views and that we are enjoying. On the right, you can see the view from the International Space Station looking at the Crew Dragon capsule. On the left is the view from the Crew Dragon capsule looking at the International Space Station. So they both are able to see each other. They're not too far away. Just a couple of kilometers. The approach initiation burn is expected to come up here in about 6 minutes. So they're coming up on just about when the Dragon is 2.5 kilometers below the station and about 7 kilometers behind it. That's about where they are positioned. We had a question come in using the hashtag #LaunchAmerica about the view from the International Space Station side. That's the view that you see on the right. Yes, that is controlled from a person in Mission Control Houston. That flight control position is called Cronus. And there he is. That is the Cronus flight position. So that person is in control of the cameras and is trained and has actually autonomous control to control the cameras. They do not need permission from the flight director to say, hey, can I point the camera in this direction or the other direction? They can go ahead and they're trained to know how to lock it in. So yes, they do have to be trained to manually look at Dragon during its approach, and especially when it swings underneath it, it's going to be kind of hard to track. But then when it holds out in front, we should get some nice, steady, high-definition views of Dragon. So yeah, let's soak in these views as the two spacecraft that are about to join with one another here at scheduled for 2:10 a.m. Pacific time. Now getting into the approach initiation phase, minutes away from the approach initiation burn, seeing each other from about 7 kilometers away.
And we did also hear a call out that the crew is in their suits already, and they are ready for the ground to come back into the cabin. So we might get some internal views here shortly, and they're getting ready for approach and docking here soon.
That's right. The approach initiation burn. That's a major burn coming up in about let's see, a little more than 5 minutes from now, scheduled for 12:31 a.m. Pacific time. That's approach initiation.
Dragon SpaceX, we are back on board with internal cameras.
We copy, you're on board with cameras.
There they are.
There is the crew back in their suits, in their seats. Looks like they're also harnessed in. Essentially their seat belts are a 5-point harness. And looks like they're all strapped in and ready for this approach to the International Space Station.
We'll get to enjoy these views periodically as the International Space Station and Crew Dragon fly over the Earth. These views provided by passes over ground stations that are taking the live feeds from the cameras on board station, delivering them past the ground stations and over to us here in Mission Control Hawthorne. The approach initiation burn is expected to last for 90 seconds, a minute and a half, and that is a major burn to take us into the approach ellipsoid, where a whole new set of flight rules has to take place. We'll have teams here in Mission Control Hawthorne as well as Mission Control Houston looking at the same procedures, the crew as well, on board Dragon, as well as the International Space Station. We should hear them communicating over the big loop that loops in the two flying spacecraft, being both the Crew Dragon and the International Space Station, as well as the two flight control teams in Houston and here in Hawthorne.
And you could see that the crew, again, is getting ready for this approach phase of the mission, and they're getting their hands back into their gloves. These suits are, the upper portion of the suit is a single piece, so these gloves are a part of that upper portion of the suit. So you could see those almost like red tags that they're pulling on, and that's because that makes it a lot easier for them to zip those gloves on and create that seal for the suit.
We can periodically get a peek from behind the astronauts looking at their screen. If you notice the center screen, that is the trajectory. You can see them on a plane about 2.5 kilometers rather below the International Space Station, and that approach initiation burn is sort of a slope that'll bring them up to the R-bar of the International Space Station, the R-bar going directly through the space station from top to bottom, and essentially that R-bar meeting at that point directly below the International Space Station. That point will be about 400 meters or about a half a mile, and that'll be the first waypoint after the approach initiation as Dragon makes its way to dock to the station. There are 2 more waypoints, waypoint 1 and waypoint 2. Waypoint 0 is 400 meters below the station on the R-bar.
And the crew is waiting for that approach initiation burn to begin.
We're expecting that in about 30 seconds from now.
And the crew is out in space, so they actually won't hear too much. They'll just kind of hear some clicks of those thrusters and pumps turning on and off.
Wow, an incredible view. This is from the International Space Station looking at the Dragon station, and Dragon are flying over the Philippines right now, about to head over Australia in an orbital daytime.
That is a pretty cool view.
Again, we're standing by. All right, and we're hearing that that burn has started. The approach initiation burn using the service section Dracos. It's a 90-second burn. The Draco thrusters on Dragon have just started to fire for the approach initiation burn. Dragon is currently 2.5 kilometers below the station and about 7 kilometers behind it. Again, this burn will swing Dragon up until it's about 400 meters or about a quarter mile directly below the station. This maneuver will also move Dragon inside one of 2 checkpoints around the station that requires a set of go, no-go poles with the different control teams. The first checkpoint is called the approach ellipsoid, or as you might hear, called the AE. It's an imaginary shape measuring 4 kilometers by 2 kilometers by 2 kilometers, essentially a large 3-dimensional oval. Before Dragon is given permission to move inside the approach ellipsoid, the capsule is configured to be on what is known as a 24-hour safe trajectory. This means if Dragon lost all control to its thrusters, it would be at least 24 hours before its trajectory would move inside the approach ellipsoid.
And again, we are currently burning for that approach initiation burn. Should be ending here shortly. And Dragon does have the ability to perform a mid-course maneuver about halfway through the journey to waypoint 0 to ensure the Dragon is positioned right under the station, 400 meters below. You've got this really very cool view on your screen of Dragon with some daylight.
Dragon SpaceX on the big loop. The approach initiation is complete and nominal. As a reminder, you now have impulsive retreat recovery cue cards available for your review.
Number copies on the big loop.
That concludes the approach initiation burn.
That's right. So the cue cards that were referenced are just the next series of milestones. They're going to track the performance of the approach initiation burn on its way up to rendezvous with the International Space Station, of course, passing through a series of waypoints, but they are going to monitor the trajectory and have the option at various points during the approach to execute some abort maneuvers. So they'll be reviewing those to make sure they are prepared. Again, we have a nominal approach initiation burn. Burn for 90 seconds. Now that's the last major burn. The crew and the ground teams will have the option to perform a mid-course maneuver should it be needed. And that would be just to fine-tune the approach to make sure the Dragon is targeting a precise point 400 meters directly below the station.
Again, we have this really awesome view from the International Space Station looking at Dragon. You can see that it is currently with the background of daylight. This view just...
Dragon SpaceX for suit leak checks.
Go ahead, SpaceX.
All right, Megan. You are go to begin suit leak checks per procedure 4.011.
Copy, that didn't work.
We just heard some communications that they will begin their suit leak checks for the crew on board. This is the same standard suit leak checks that they did when they were at the O&C building getting suited up for flight, as well as when they ingressed on Dragon initially. Again, they did doff their suits for the ride towards the International Space Station, but now they have donned their suits again. So because they have put these suits back on, they're doing another suit leak check to make sure that the suits are ready to go. Again, the suits are there in case of any cabin depressurization. So just making sure that everything is functioning properly prior to docking with the space station.
All right, we're tracking the Dragon now about 6.6 kilometers, or about 4 miles away from the International Space Station. We are tracking an additional maneuver, a mid-course maneuver that would happen inside 22 minutes from now, expected at about 12:58 a.m. Pacific time.
SpaceX Endeavour on Dragon to ground. We are ready to initiate suit leak check.
Dragon SpaceX, you are go to command initiate suit leak check.
Copy inward.
All right, so that's suit leak check coming up. That's going to be another major key event. Now that we're inside the, or about to enter into the approach ellipsoid, we are in joint operations. So the Dragon control teams here in Hawthorne are working with the flight controllers over in Mission Control Houston, and need to follow a joint set of flight rules now that we're in a very dynamic period of the flight inside the approach ellipsoid, or about to pass into it. That will be critical to have an extra safety precaution of suits pressurized, just in case of any event that there would be a cabin leak. The crew themselves will be protected from any leak should that occur. Now, once the Dragon rather is docked to the station and holding pressure.
Dragon SpaceX, we see the onboard caution for RGPS-3. There's no crew action required at this time.
We copy.
What you're seeing behind Dragon from this view is Australia. The Dragon and International Space Station on a southeasterly course, heading towards the South Pacific Ocean. They're going to enter into an orbital nighttime here soon, so the views will get slightly darker through this first part of the approach phase, passing into the approach ellipsoid. Again, during this after the approach initiation burn, the crew themselves have their suits configured and are undergoing a leak check. We're expecting to wrap up that leak check in just a few seconds. And we should hear a status of the leak check from here in Hawthorne.
And it looks like we got some cabin views there on your left-hand screen. Again, we are able to provide these once Dragon does pass over ground station. So it is a bit intermittent.
SpaceX Endeavour, we saw 4 good leak checks.
SpaceX copies and concurs for good suit leak checks.
We heard some confirmation that those suit leak checks are now complete and they all are functioning properly in preparation for this approach to the International Space Station. And again, we have that internal view of Crew Dragon. All 4 crew members are strapped into their seats. They are preparing for the final maneuvers to make their way to the International Space Station. And this is a view from the International Space Station looking at Dragon as that dot in the center of the screen with the Earth in the background.
Very cool. We'll get to appreciate these views from the cameras on board the station, looking back at the Earth for just a little while longer. We're about to cross over the Terminator line. So the views you're seeing here will start to get just a little bit darker as we pass into an orbital nighttime over the South Pacific Ocean.
Again, if you're just now joining us, this is a live view inside of Crew Dragon. This is the Crew-2 mission.
Dragon SpaceX for RGPS caution.
Go ahead, SpaceX.
All right, we still have 5 converged filters for RGPS, and we only need 1, so we are not going to be troubleshooting at this time. Dragon is still go for approach. How copy?
Endeavour copies. No troubleshooting, so go for approach.
We just heard some call-outs that they did have a caution notice, but it sounds like it is nothing to worry about, and they are still go for approach. Again, we have completed the approach initiation burn.
All right, you're hearing some chatter over Dragon to ground about the RGPS. These GPS units use position data to transmit it from the International Space Station to perform relative GPS navigation. There are 6 on board the Crew Dragon. Only 1 is needed for this phase of flight. So we're in a good position as we're in the approach and docking phase of Crew Dragon's eventual arrival to the forward port of the International Space Station. As promised, the views of Dragon starting to get darker as we enter into an orbital nighttime over the South Pacific Ocean. Getting good views from inside the cabin of Crew Dragon to see that center screen, monitoring the trajectory, just really following that line up to the big dot, the big center there. That is the International Space Station.
And again, Dragon is flying autonomously, so they are not manually flying Dragon. That is not what they're using the display panels for. They are just using those displays to monitor their progress along the way. Again, we are getting some intermittent views inside of Crew Dragon as we pass over ground stations. And as Gary mentioned, we no longer have that daylight view. So that background is now that black space, dark view.
Now we're expected to be in a sunrise as station makes its way through this approach phase of flight. It's planned to execute an approach initiation mid-course burn, and then teams will conduct a go, no-go to approach waypoint 1, which is about 400 meters directly below the International Space Station. We should be expecting a sunrise about that time, but we'll be in an orbital nighttime until those next milestones. Contact and capture at 2:10 a.m. Pacific time is scheduled to occur just before an orbital sunset. On Dragon's approach, it's about 3,700 meters or 3.7 kilometers away from the International Space Station as it approaches inside 2.5 miles from the International Space Station.
And this portion of the mission is, even though they are very, very close to the station, it is some precise maneuvers, so they do want to move very slow and steady with multiple checkpoints along the way to ensure that the spacecraft is safe and the space station is safe as well. So we are taking our time here. So even though we do get closer and closer, it will still take just a little over an hour or so for the Crew Dragon to dock with the International Space Station.
Meanwhile, again, Crew Dragon is not the only spacecraft in flight right now. It's about to meet up with the International Space Station. We're hearing from the control teams over there that the International Space Station itself has maneuvered to its docking attitude. The station itself undergoing a series of procedures to make sure it is prepared as an orbiting complex to receive the Crew Dragon. This view from the Dragon itself.
And what an incredible view that is. You can really see the outline of the International Space Station. Really shows you how close they are getting to docking.
Absolutely. That view is from about 2 miles away as the station makes, or as the Dragon makes its approach to station.
Now we're looking at Dragon from the International Space Station in this view that you're seeing here on your screen.
A common question we get relative to International Space Station cameras has to do with all the different colored pixels you see from this camera view. The pixels themselves have been exposed to the radiation environment that is in low Earth orbit. So cameras every once in a while will have dead pixels experienced from some of the radiation that is in this environment.
And you can see the camera kind of moving and adjusting as Dragon makes its way to the space station. And that is because it's being controlled by a human on the ground. That is in Mission Control, Houston.
That's right, that position being Cronus. They're locked on to Crew Dragon Endeavour. All right, so we'll have intermittent dropouts from the cameras aboard the International Space Station. Of course, they're flying at 17,500 miles per hour, and they're using tracking and data relay satellites, geosynchronous satellites that are positioned about 23,000 miles away from the Earth. So they'll just have periodic handovers between some of the satellites as the two orbiting spacecraft make their way around the Earth. They're now over the Pacific Ocean in orbital nighttime. They're expected to be there for quite some time. We're coming up on a couple of milestones, one of them being a mid-course maneuver, just another small burn just to make sure we're in line, to make sure we're getting to that first waypoint. There are 3 waypoints, waypoints 0, 1, and 2, and waypoint 0 is 400 meters directly below the International Space Station.
Again, if you're just now joining us, we have completed the approach initiation burn. And as Gary mentioned, we are coming up on the next burn, being the mid-course burn, in about a little under 15 minutes or so.
Dragon's about 2.5 kilometers away from station now, just a little more than 1.5 miles.
If you're just now joining us, we are monitoring and providing updates on the Crew-2 as they make their way to the International Space Station. The view that you're seeing on your screen is of Mission Control Hawthorne. And as we get live views of Dragon, from Dragon as well as from the International Space Station as they pass over ground stations, we will provide those, but they will be intermittent, as you can see here. And there on your right-hand screen is Mission Control in Houston. So on your left-hand screen is Mission Control Hawthorne, where we are working the Crew Dragon, whereas Mission Control Houston is working the International Space Station.
Both control rooms looking over a similar set of flight rules. These are joint flight rules by both teams, both understanding what each spacecraft is doing to prepare for Crew Dragon's arrival.
And they currently are in integrated operations, so they are working together for these final maneuvers for Dragon to approach and dock to the International Space Station.
Dragon still making its way to meet up with the International Space Station. It's a little more than 1.25 miles away, or just more than 2 kilometers. We're tracking a mid-course burn coming up in approximately 3 minutes from now.
Again, if you're just now joining us, we have completed the approach initiation burn. We are coming up on a mid-course burn here shortly in just under 10 minutes. And then following that mid-course burn, we will be making our way to waypoint 0, which is just a checkpoint. If we need to, we can pause Crew Dragon there until it's ready to make its way to waypoint 1. But if everything looks good by the time it gets to waypoint 0, it can just continue on without holding at waypoint 0 and just continue on to waypoint 1.
Dragon SpaceX for RGPS 3 caution.
Go ahead, SpaceX.
All right, we looked into the RGPS fault, and we are comfortable resetting this filter to try and bring it back to regain additional fault tolerance, but we are still go for the upcoming maneuver. How copy?
We copy all. Thanks for the update.
All right, so the team's on the ground going to try to recover one of these 6 RGPS units that provide relative navigation. They are redundant systems, but they're going to go ahead and try to recover it as we await the mid-course burn scheduled to come up here very shortly. The performance of that burn should set them up to determine its alignment with waypoint 0, which is 400 meters or about a quarter mile directly below the International Space Station. And whether or not it will proceed past that point, which we've seen for the past couple of flights on Dragons. They've proceeded past the waypoint 0 mark and swung up and out in front of the station to the 220-meter mark, which is designated as waypoint 1. All right, we got confirmation that the mid-course maneuver has started. All right, we're about a minute into the mid-course maneuver.
Dragon SpaceX on the big loop. Mid-course correction maneuver is complete and nominal. Trajectory has converged on waypoint 0.
Denver copies all. Good news.
All right, you just heard that confirmation from the core here in Mission Control Hawthorne. We just executed the 90-second mid-course maneuver, which again is done about halfway from our starting point of approach initiation to waypoint 0. It's a small burn just to fine-tune the approach, ensure we're targeting a precise point 400 meters directly below the station.
Once Dragon arrives at 400 meters below station, it will be at what is known as waypoint 0 and will be the first checkpoint during our approach. The vehicle can hold here at 400 meters, but if all systems check out, then it can just continue on to approach waypoint 1. We are just waiting for confirmation once we get to waypoint 0.
Dragon, SpaceX for our GPS caution.
Go ahead for our GPS.
All right, Megan, we had a successful convergence of the RGPS USOS filter. So we are back to having 6 converged filters. Still go for approach, and we are going to be clearing your onboard alert. How copy?
Endeavour copies all that. Good news, thanks.
All right, that confirmation from the ground, the recovery procedures that they put forth to recover one of the 6 RGPS units was successful. Now they have 6 up and running, fully functional RGPS. That'll help with the relative navigation through this next phase of flight with a good mid-course maneuver that sets us up, and the Dragon itself has been confirmed converged onto waypoint 0, which is 400 meters below the International Space Station. All right, we're following along Dragon's trajectory, now completing both the approach initiation burn and a mid-course maneuver to get it in line with that first waypoint, waypoint 0. That's 400 meters directly below the International Space Station. We're looking to get confirmation that the station is passing inside the approach ellipsoid, now just a little more than a kilometer away and approaching fast. We should get that call shortly. In addition, we're about 15 or so minutes away from arrival to waypoint 0. Should be conducting a go, no-go with both of the control teams that you see on your screen. The left is mission control teams in Hawthorne looking after the SpaceX Crew Dragon vehicle, and mission control Houston looking after the International Space Station, both of course looking after each other's vehicles and monitoring the approach through a set of joint procedures. So that go, no-go poll will ensure that Dragon is looking good to proceed with converging onto waypoint 0, and that the International Space Station is ready to receive Dragon as it makes its way through these next few milestones. Dragon's now less than a kilometer away from the International Space Station inside the approach ellipsoid.
We got the view from the International Space Station back, looking at Dragon as it's making its approach. And it is orbital nighttime, so the background is dark, but you can see that blinking light on the screen. That is Dragon in the distance.
The International Space Station is over the South Pacific Ocean still. It's on a northeasterly course and will pass over Panama, over Central America very soon, and then over the Caribbean. As it makes its way over the Atlantic Ocean, that's where the terminator line is, so we should start seeing views get a little bit brighter. Sunrise is expected in about 16 minutes from now.
Again, we're just now waiting. We're about under 10 minutes from the go, no go to see if we can proceed.
Dragon SpaceX on the big loop. Ground is go for approach 0, and we'll be enabling the maneuver shortly. Expected maneuver start time is at 0819 UTC.
Copy 0819 for the maneuver.
Good readback. And Dragon will nominally continue approach through waypoint 1 towards waypoint 2 without stopping at waypoint 1.
Endeavour copies.
And we got that confirmation that Dragon will just continue through waypoint 1 and head on over to waypoint 2. No stopping there, so.
That's good, and that means the ground teams both in Mission Control Hawthorne and Houston have pulled go to proceed with that. So Dragon itself will go through waypoint 0, 400 meters below, and when it swings up and out in front of the International Space Station at 220 meters, it will not pause. It's going to go ahead and head right in.
And Station Houston on the big loop. Expect to start monitoring Dragon in approximately 25 minutes.
Station copies. Standing by.
The voice you heard from the ground was from Mission Control in Houston. That's Capcom Kathy Bolt talking with Victor Glover aboard the International Space Station. It's his role today to monitor Dragon's approach. It's a busy day for the astronauts aboard, but he's scheduled to head over and start the monitoring procedures using the RPOP, or Rendezvous Proximity Operations Panel. It provides telemetry from the Crew Dragon as it makes its way, so he'll have another view. Of course, there's a lot of support from both of the control centers that you see here on your screen, monitoring as well. Victor Glover, though, will have the benefit of having a view for himself. He'll have a window and be able to look at Dragon's approach through the cupola window. We're about 10 minutes to waypoint 0. Dragon continuing its approach. The mid-course maneuver sets Dragon up to rendezvous with waypoint 0, which is 400 meters directly below the station. Dragon is now inside 600 meters, so 200 meters to go.
If you're just now joining us, and you're seeing on the screen this dark screen with a blinking light, this is a view from the International Space Station looking at Dragon, as Dragon is getting closer and closer to the station. We'll be docking with the station in just about an hour with our Crew-2 astronauts on board. Once we finish docking, there will be a process to ensure that both the station and Crew Dragon are safe with opening the hatches before the crew can ingress. So crew ingress to the station will happen approximately 2 hours after docking is complete. Again, Dragon is getting very close to the station, but these are some precise maneuvers that it does need to make. Despite how close it is to the station, we want to make sure that we are checking in on both vehicles each step of the way to ensure the safety of both vehicles throughout this entire process prior to docking, prior to Crew Dragon docking with the space station.
The views of Dragon should get a little bit lighter. And we should be able to see Dragon clearly as it makes its way to, or crosses, rather, waypoint 0. What you're seeing now are the navigation lights on Dragon. The blinking is the navigation light you can see on the forward end of Dragon, exposed by the open nose cone. And you can see the green and red lights there. Green denoting the starboard side and red denoting the port side. So the view you're seeing is an upside down view. Again, Dragon is approaching from underneath the station and will swing up and out in front of it to align with the docking axis at the forward port of the International Space Station.
When we say beneath, we're talking about basically between the Earth and the space station.
Right.
And when it swings up and out in front of the docking port, it will be adjacent to the station.
Dragon SpaceX for Dragon Eye status.
Go ahead, SpaceX.
All right, Megan, for awareness, we may lose Dragon Eye convergence prior to or during approach 0. If we were to lose Dragon Eye convergence prior to approach 0 starting, we would enter into go to 0. And if we lost Dragon Eye convergence during approach 0, we would temporarily transition to approach 0 coast. And then if this happened, it would result in onboard alerts. How copy?
We copy all.
The Dragon Eye system mentioned on board Crew Dragon is an optical navigation system that measures the vehicle's relative position for precision approach and docking. So the data we're seeing of Dragon's distance from the station and its rate of approach, partially coming from those Dragon Eye systems. Core mentioned a slew maneuver as Dragon approaches waypoint 0. That's expected here in about 2.5 minutes. It'll help to align and converge with waypoint 0 directly below the International Space Station. All right.
Wow, we've got a very close-up view of the International Space Station from Dragon. And you can see how close we're getting. Again, this is from below the station, meaning between Earth and the station. And now we have some internal views of Crew Dragon.
International Space Station is now 260 statute miles over Panama, close enough to pass over the ground stations over the Cape in Florida, providing some of these incredible views from Dragon.
The crew is in their suits and seats, patiently waiting as Crew Dragon approaches the International Space Station, which is what you're looking at on your screen. This is a view from Crew Dragon looking at the station.
You can see this is almost directly below the International Space Station. We're coming up on the R bar, or essentially directly below. That's waypoint 0, coming up in less than a minute and a half.
SpaceX for awareness, the geo filters did just converge on Dragon Eye, so we do not expect them to drop out.
That's great news, SpaceX. Thanks.
Crew continues to monitor Dragon's approach to waypoint 0, coming up in about a minute. The lights from the outside of the International Space Station illuminating the radiators. Those are those long rectangular shapes you're seeing coming down at the bottom of your screen. Almost directly below the International Space Station at waypoint 0, 30 seconds and counting.
And we did hear the Corps mention that they will not stop at waypoint 0, so they will just pass through this checkpoint.
Okay, and we have confirmation we just passed waypoint 0. The service section Draco thrusters fired to converge with the approach maneuver to meet up with waypoint 1. That'll be directly in front of the International Space Station. So now we're making our way, now not officially behind the station, making our way in front of the station.
Dragon, SpaceX on the big loop. Approach 0 is in progress and the trajectory has converged on waypoint 1. Expected arrival at waypoint 1 at 0845.
Zero 0845 at waypoint 1. Thanks.
And as expected, as we pass waypoint 1, we're starting to get some of the sun illuminating the station. Hopefully we'll still continue to get some of these views from the cabin and from the exterior of the Dragon looking up at the International Space Station as we pass into an orbital sunrise over the Atlantic Ocean. Now 261 statute miles over the Caribbean. Again, we passed waypoint 0 and initiated an approach maneuver, approach 0, firing Dragon's service section Dracos to align and converge with waypoint 1 being directly in front of the International Space Station from this view. It's at the top of your view. That's where the International Docking Adapter is. You can sort of make it out now that the sun is illuminating the station itself. So that approach maneuver was successful, and Dragon itself converged onto waypoint 1. We did get a word from the ground teams here that the intent is to proceed past waypoint 1. So once it's directly 220 meters in front of the International Space Station, it will not pause. It will continue to move in. Inside the keep-out sphere, which is about 180 meters away from the station, and it will continue on to waypoint 2 at 20 meters. At 20 meters, it will pause and conduct a go, no-go poll to proceed past the waypoint 2 and in for a soft capture. Soft capture estimated less than 50 minutes from now at 2:10 a.m. Pacific time.
We have the sun shining very bright on the International Space Station right there. As we are entering sunrise, as Gary mentioned. Again, this is a view from Crew Dragon as it's approaching the International Space Station. And it is moving from below the station or between Earth and the station towards being adjacent or in front of the station.
So we'll hopefully continue to get these views for as long as possible. They are absolutely incredible. And then, of course, we have cameras on the International Space Station itself that'll be able to look at Dragon as it approaches the docking axis a little closer. Actually, yeah, we're getting some views even now as the Dragon's underneath and in front of the station. So we're expecting to converge on waypoint 1. Dragon, you're seeing from this view here, will make its way into the docking axis directly in front of the International Space Station. That whole maneuver expected to take about 21 minutes from now. And again, the plan will be to, as of now, will be to proceed past waypoint 1 and pause at waypoint 2 about 20 meters. So as Dragon makes this maneuver, you were seeing mostly the nadir side, or the side of the International Space Station that faces the Earth. Now, as we swing up in front of the station, you're starting to see more features, including some of the solar arrays, each of those arrays about the size of a basketball court. And those arrays will provide enough power for all of the equipment on board the International Space Station, including communications and navigation and environmental control and life support equipment, as well as hundreds of experiments throughout the orbiting laboratory. Once Dragon docks to the International Space Station, an umbilical will be provided by the space station to provide power from those solar arrays to Dragon throughout its 6-month stay aboard.
Gary, you're mentioning the size of some of the components on the space station. But the space station altogether, what we're looking at here is approximately the size of a football field, right?
That's right. Oh, fantastic views from the International Space Station. You can see very clearly the Terminator line. So that's the line between light and dark now. That's over the North Atlantic Ocean. The International Space Station on a northeasterly course. It will cross over Great Britain when it gets over the Atlantic Ocean, over the pond to Europe. It will first cross over Great Britain.
Again, more awesome views from the International Space Station, looking at Dragon with Earth in the background there. And Dragon is currently swinging up to become adjacent to the space station, and it will be moving to be right in front of the docking port.
Right, I just passed the marker waypoint 0, that waypoint being directly below the International Space Station, where it executed an approach burn using the service section Dracos. That helped it to converge with that next waypoint right in front of the station. So now we're at a little more than 310 meters away from the station. As it makes its way up front, it will continue to get slightly closer. Waypoint 1 directly in front of the station is about 220 meters. So it'll get incrementally closer as it makes its way in front of the station.
And these views from the space station look incredible. I can only imagine what the astronauts on board the station get to see with their own eyes. That looks amazing.
They had a lot of time in orbit. Of course, after an orbital insertion, about 9 minutes into the flight, and then spacecraft separation from the Falcon 9 that delivered Dragon into orbit 12 minutes into the flight. For the most part, up until this point, they've been flying around the Earth. Had a couple of laps, couple of sunrises, and have been able to enjoy these views. Of course, there's a sleep period as well.
And now you can kind of see how Dragon is swinging up to be in front of the station, because now you can see a portion of the space station in the view.
That's right, these cameras on the truss segment of the International Space Station, so these cameras likely on the nadir side of the truss segment. As the station makes its way up, as Dragon makes its way up to align with the docking axis, we may lose some of the views here, but there are cameras on the forward end of the International Space Station. They'll be able to pick up Dragon as it makes its way to align with the docking axis. Those cameras pointed straight ahead to monitor the operations just like this for the approach and docking of visiting vehicles. Teams will continue to evaluate the progress of Dragon's approach, making sure that all systems are go for approach and docking. Right now, we're still tracking a docking time at 2:10 a.m. Pacific time. That'll be 40 minutes from now. And so this will be the last pass over daylight. So for the remainder of our coverage until docking, as long as we proceed through these steps nominally, we should be able to see everything in an orbital daytime.
And just as a reminder, after Dragon docks with the station, it will take a little over an hour and a half to 2 hours for the hatches to open and for crew to ingress onto the space station. And this is another cool view from the, I believe this is the forward side of the International Space Station.
That's right, and those cameras on the truss segment, on the port truss of the International Space Station, what you're seeing, the features there are the Japanese robotic arm and the Japanese logistics model up at the, sticking up at the top of the Japanese experiment module that houses many of the experiments on board the International Space Station from the Japanese side. There's also an exposed pallet there. There it is at the bottom of your screen with additional experiments. You can sort of see the Dragon out there in the distance, the cloud coverage over the North Atlantic Ocean as the Dragon makes its way up to the docking axis. Dragon's about 307 meters away from the station. The plan now is to proceed past waypoint 1. Waypoint 1 being 220 meters directly in front of the International Space Station, right in line with the docking axis. When it starts to move in, it'll pass into the keep out sphere. This is an imaginary line, extends about 180, 185 meters directly in front of the station. And there's new flight rules that come into play when Dragon makes its way inside the keep out sphere. Victor Glover, who's monitoring from the station side, if he sees any anomaly with his data, has the ability to command an abort from the station side. But of course, an abort can be issued from inside Dragon as well, or from the ground. And of course, Dragon, once it reaches the docking axis, has about 20 hours of power, so it can hold there for quite some time and can reattempt to dock as necessary. But so far, things are looking pretty good for today, as we're tracking for a docking at 2:10 a.m. Pacific time.
And again, a really cool view from the International Space Station, looking at Dragon as it gets closer and closer. It's currently swinging up to be in front of the docking axis, which will mean that Dragon will be...
Dragon SpaceX for approach 1 status.
SpaceX.
All right, Shane, we are currently tracking the sun's relative position and how that is impacting our ability to monitor the retroreflectors with the Dragon eyes. We are going to make an assessment at approximately 110 meters to see if the sun's position will impact the Dragon eye convergence. If we deem that it might impact Dragon eye convergence, ground is going to command a hold. However, if at 110 meters, it is early enough where this will not be an issue, it will not impact approach 1, and Dragon will continue to waypoint 2.
We copy it all, thanks.
Okay, so what you just heard from there, first of all, down on the Earth, these beautiful shots. The International Space Station is just passing over Ireland. The body you see there is the United Kingdom. We're passing over Europe, and we're about to pass over the Netherlands and Germany as well. The calls you heard as we pass over these parts of Europe The sun itself will come up and behind the International Space Station.
On the big loop, monitor approach per step 1 of 1.104, Crew Dragon approach and retreat monitoring.
Station copies and work.
All right, and that was Kathy Bolt, Capcom and Mission Control Houston. Victor Glover aboard the International Space Station, confirming he's standing by, monitoring Dragon's approach. So he'll be looking at the same telemetry that the ground teams are and the crew aboard Dragon as well. Now, the call you heard from the core was once Dragon makes its way past waypoint 1, 220 meters in front of the station.
Dragon SpaceX on the big loop. Expect reconfiguration of the C2V2 return link shortly.
Denver copy.
All right, so once Dragon makes its way inside waypoint 1, the 220-meter mark, crosses into the keep-out sphere, the ground teams will do an assessment at about 110 meters. See the position of the sun. The sun might be a little bit too far behind the space station at the time and interfere with some of the optical cameras, the optical equipment, navigation equipment, the Dragon eyes. So they'll do an assessment and may issue a hold if necessary, depending on the position of the sun and how they're interfering or how they affect the Dragon eyes. Also, they're going to check the C2V2 common communication for visiting vehicles. There's a link between the two spacecraft now. There's a C2V2 on Dragon and also on the International Space Station that provides telemetry. A lot of that telemetry is what Victor Glover aboard the station is monitoring using his Rendezvous Proximity Operations Panel. So all this coming up very soon. Dragon inside 300 meters, 284 and closing. Again, 220 meters is the point where we meet up with waypoint 1 directly in front of the International Space Station. That's expected to come up in a little less than 7 minutes. Still getting great views. Those cameras trained, of course, on the star of today's show, the Crew Dragon, but we're still getting some glimpses of the Earth right underneath the station. 265 statute miles directly over Frankfurt, Germany, passing over Eastern Europe, and eventually will cross over the Black Sea. .270 meters and closing. Crew Dragon expected to converge with waypoint 1 directly in front of the International Space Station in less than 5 minutes. You can see the views right over the shoulders of Commander Shane Kimbrough and pilot Megan MacArthur. Kimbrough on the left, MacArthur on the right from that view.
from this view from the International Space Station, you can see what we were mentioning earlier, where Dragon was below the station. You could see that previously when it had Earth in the background. Now it is almost adjacent, or almost in the same orbit as the International Space Station, as it's making its way to the docking axis at waypoint 1. Now this maneuver from below the station to in front of the docking port is almost complete, just a few minutes away.
Getting great views from all around, from the station side, from the Dragon side. The outline of the station you see on the displays inside Crew Dragon is in line with the position of where Dragon is relative to the International Space Station. It's almost at the docking axis, about 2.5 minutes to go until it converges with waypoint 1.
And as a reminder, Dragon is flying autonomously, so they aren't using those display panels to fly Dragon. They're just using them to monitor each step of the way. So the crew is basically just patiently waiting until they dock with the station.
Now seeing Dragon in a better view, a lot more clear now that it's only 240 meters away. You can see the nose cone clearly deployed, extended towards the space-facing side or zenith side.
A really good zoomed-in view, and you could almost make out those 4 bulkhead thrusters on the forward portion of the Dragon capsule.
There you go. The Cronus is adjusting the aperture of the station cameras.
Dragon SpaceX on the big loop. Approach 1 and soft capture ring extension will begin shortly. Dragon will continue to waypoint 2 with the additional lighting assessment occurring at 110 meters as previously noted. For awareness, if sunlight results in the loss of the Dragonite geofilters, Dragon will autonomously retreat back to waypoint 1, remaining on closed loop control using the time of flight filters. How copy?
We are in a handover period, so we may have missed a call as we were switching from TDRS satellites. We're looking at about 20 seconds to go until we converge with waypoint 1. There's going to be an approach burn maneuver using the Draco thrusters. That's called approach 1, and that'll move Dragon from right in front of the docking axis, 220 meters away, and start moving in, closing in to waypoint 2, just 20 meters away from the docking axis. Of course, they'll be monitoring along the way.
We did hear the Corps mention that they are going to have a checkpoint to make sure that there isn't too much sunlight on the space station, which will prevent Dragon from docking. If that does happen, Dragon will autonomously back out and wait until the sunlight has cleared to ensure a good docking with the space station. because this is all autonomous, it uses some visual cameras to align with the docking port. So it's really important that we don't have that sunlight getting in the way.
SpaceX Endeavour on the big loop, sound check.
SpaceX has you loud and clear on the big loop. How me?
Very loud and clear. Your last call, we copied most of it, but you cut out towards the end there. I'm not sure if there's anything important for us.
Copy. I'm going to repeat the end of the call. We did have a TDRS handover. Just for awareness, following the lighting assessment, if we continue but sunlight results in a loss of the Dragon Eye geo filters, Dragon Eye will autonomously retreat back to waypoint 1, still on closed loop control using the time of flight filters. How copy?
Okay, we copied all. Thank you very much for repeating.
No problem, Shane. And for awareness, the C2V2 link reconfiguration has been completed.
Copy, C2V2 complete.
And there, the Corps just reiterated that they will be checking to make sure that the sunlight is not in the way of the visual systems between Dragon and the space station. If that does happen, Dragon will autonomously retract and wait until we do get some good visual views for these systems to dock with each other. So
that's right. Crew Dragon resilience actually coming into view a little bit clearer now from the cameras aboard Dragon. Dock to the zenith port.
Yeah, that was on the upper portion of the screen.
That's right. Now again, to reiterate, Dragon has passed waypoint 1, 220 meters in front of the station, executed a burn maneuver to go ahead and move in, so we're in approach 1. And it's heading towards waypoint 2. Now inside the keep-out sphere. It's currently in the process of extending its soft capture ring that'll be used to dock to the international docking adapter of the forward port. We're monitoring the visual systems of Dragon. It would execute an automatic retreat if the sun was interfering with the optical systems as it makes its way towards an approach. We're at about 150 meters away from the station.
And we have such a great camera view here. You can really see the detail on Dragon. Again, those 4 bulkhead thrusters. You could almost read the logo, the Dragon logo on the side of the vehicle.
That's right. We'll get even better views as it makes its way even closer to make contact and capture with the space station.
There it is.
Yeah, based on the trajectory here, we may even anticipate a capture a little bit earlier than anticipating. We were looking at about 2:10 a.m. Pacific time. It might be at maybe closer to 2:07 p.m. The features of the space station coming into view very clearly.
Yeah, you can see a lot of the detail there. And as you mentioned, the Crew-1 Dragon.
This is SpaceX station on the big loop. Procedure review complete, ready for docking.
Houston copies.
All right, that was confirmation from Victor Glover aboard the International Space Station. From the space station side, he is go for docking. The soft capture ring itself is fully extended. We're 115 meters in closing.
Looking at your screen, the port that we are going to be docking with is directly in the middle of the screen, that circular area on the International Space Station.
Station Houston on 2 for Ike regarding SSC 17 and D2DM. We are seeing some strange configurations on the video, and we would like to close and restart that. We can take care of that from the ground if you would like. Absolutely. If you're seeing nominal, that works for us.
Okay, so Victor Glover aboard the station still has...
Put that in work.
And Dragon, SpaceX soft capture ring extension is complete. Additionally, we did beat the sunlight for the Dragon Eye filters, so we are not going to command a hold.
Never copies off.
All right, so that's great news. We passed the 110-meter checkpoint that the ground operators were referencing, making sure the sun wasn't interfering with the optical sensors, the Dragon Eye, that are part of the guidance and navigation and control system aboard Dragon. We passed that check mark. We're good to go. We beat the sun there. So we're now inside 80 meters and closing. Dragon will pause at 20 meters. That's designated as waypoint 2 to conduct a go, no-go poll for the readiness on both the Dragon side and the International Space Station side, making sure everyone is good for docking. If we are go, we expect to dock during this pass over an orbital daytime. Expected in less than 20 minutes. Some of the features there, you can see a lot of the visiting vehicles on board station. At the bottom is a Russian Soyuz vehicle that delivered crew to the International Space Station. Just in front of that, or actually above that, is the Crew Dragon Resilience docked to the Zenith port. Once Crew Dragon Endeavour arrives, there will be 2 Crew Dragons attached to the space station.
In this view from Crew Dragon looking at the International Space Station, it looks like it's this very slow and steady movement, but in reality, they're moving at 17,500 miles per hour.
The rendezvous operations are absolutely incredible. You can sort of see the Northrop Grumman Cygnus cargo craft as well, some of the ultraflex solar arrays coming into view a little bit clearly.
And you can see that Crew-1 Dragon vehicle on the top of your screen. Once Crew-2 docks to the International Space Station, we will have 2 Crew Dragons docked at the same time for the first time.
That view right there was truly a representation truly of an international cooperation there. The U.S.-built Node 2 is where the Dragon will be docking today. It was flanked by the European Columbus module and the Japanese GEM.
Endeavor on the big loop, visors down.
SpaceX copies. Visors are down. We may enter into a hold at waypoint 2. We are still awaiting ground go for final approach.
Endeavor copies.
The detail of this camera view is pretty incredible. Here from the International Space Station, watching Crew Dragon as it is slowly approaching.
And as expected, Dragon holding at waypoint 2. It's at about 20 meters right in front of the docking axis.
And if you're just now joining us, we are just waiting for a confirmation for go for docking. Currently holding Dragon at waypoint 2. And again, it looks like Dragon is just paused and not even moving, but again, as we just mentioned, both the space station and Crew Dragon are actually moving at approximately 17,500 miles per hour. So it's pretty incredible how it can hold these speeds so that it looks like they are just completely paused.
That's right. Teams on the ground, both from the station side in Mission Control Houston and Mission Control Hawthorne, just checking and verifying all systems are go to proceed with docking.
And when we do begin docking, there will be two portions of this. There will be a soft capture followed by a hard capture. The soft capture will be a soft capture ring that basically just connects the Crew Dragon to the space station to enable the hard capture, which will be 12 hooks that will attach Dragon to the station.
Again, we're standing by the International Space Station, flying over the Indian Ocean now, just south of the Indian border. It's heading on a southeasterly course just south of Australia and should cross over the Terminator line into the Pacific Ocean into an orbital nighttime. The expectation is for Dragon to depart here from waypoint 2 and proceed on with docking ahead of orbital nighttime to beat the sun.
You can see this camera moving around. Again, this is controlled from the ground from Mission Control Houston. And they're maneuvering this camera around so we can just get a more detailed view of the Crew-2 Dragon Endeavour patiently waiting, docking to the International Space Station.
Dragon on its second flight, about to dock to the forward end of the International Space Station for the second time.
And Station and Endeavour on the big loop. Ike, we are not able to recover that video for the D2DM, so you can close that window, and we should be ready to press into final approach shortly.
Station copies.
You did hear that call out speak out to Ike. Ike is actually referring to Victor Glover. That is just his nickname.
Dragon SpaceX on the big loop. Ground is now go for final approach. Upon confirmation of crew readiness for final approach, we will enable the approach. Please confirm crew readiness, and a reminder, once Dragon is inside the crew hands-off point, retreat and breakout are no longer permitted.
Crew is ready for final approach.
And got some good words that the crew is ready for the docking to the International Space Station. They no longer will have control of any aborts. If there is an abort needed, it will have to be done by the Dragon autonomously.
Houston on the big loop, monitor per steps 3 and 4 and 1.104.
Station copy.
Again, we are now moving into the CHOP, which is the crew hands-off point. As I was mentioning earlier, if there is an abort, it will need to be done autonomously by Dragon.
All right, and we did get confirmation. Approach 2 has been initiated. So Dragon now making its way inside the 20-meter hold point at about 18 meters and closing. Final approach of Endeavour to dock with the International Space Station has started. Docking expected in about 3.5 minutes from now.
And you can see on your screen as Crew Dragon slowly approaches towards that port for docking.
That's right, we're 13 meters and closing, making a slow and methodical approach to the docking port. That's on the forward end of the International Space Station, that international docking adapter where Crew Dragon Endeavour has docked once before.
Meters.
Copy, 10 meters.
What that call out was Crew Dragon is just 10 meters away from the International Space Station as it continues its approach for docking. And docking will occur in 2 phases. There will be a soft capture followed by a hard capture. And what that hard capture means is 12 physical hooks will connect the Dragon to the space station.
Great views. Dragon just 6 meters away as the station and Dragon fly in tandem 263 statute miles over the South Indian Ocean in the background.
5 meters.
We're 5 meters and closing.
Copy 5 meters.
Really start to see the detail on Dragon there as it is closing in on docking.
That's right, 2.5 meters, 30 seconds. Crew hands off point was called out.
Dragon, SpaceX on the big loop, soft capture confirmed.
Copy, soft capture confirmed.
Great news with that call out. That soft capture is confirmed.
That's right, that soft capture time, 2:08 a.m. Pacific time, 4:08 a.m. Eastern. The station and Dragon connected 264 statute miles over the South Indian Ocean. Endeavour connected to International Space Station for the 2nd time.
And there are still a few steps to complete before Dragon is securely attached.
Dragon, SpaceX on the big loop, soft capture ring retraction in progress.
That's good. The ring retraction is happening. Ring retraction happening as expected. And after the ring retracts, 12 hooks will latch, 6 at a time, to perform a hard capture, and will officially mate Dragon to the International Space Station.
Got this really awesome view of Dragon as it is connected to the port, currently making progress on hard capture.
Soft capture ring retraction does take some time. It is continuing at its anticipated speed. Things are looking good. Again, this is the first in a series of steps to officially mate Dragon to the station. If you're just joining us, we heard the call out for soft capture confirmed at 2:08 a.m. Pacific time, 4:08 a.m. Eastern time. Station and Dragon were 264 statute miles over the South Indian Ocean at the time of contact and capture. We're still in the process of retracting the soft capture ring and anticipating proceeding with the hard capture sequence, where 12 hooks will drive to officially mate Dragon with the International Space Station's International Docking Adapter at the forward port. Crew Dragon Endeavour docked to that forward port for the second time.
Dragon SpaceX on the big loop. Ring retraction is complete. Docking sequence is holding for MCS reconfiguration.
Endeavour copies off.
If you're just now joining us, as you can see on your screen, Crew Dragon has made contact with the International Space Station. And we're currently in progress of...
Endeavour and Station, MCS is configured, proceeding with hook driving.
Endeavour copies. Station copies.
Great timing there. This is now the beginning of the hard capture sequence. This is where 12 hooks will latch between Dragon and the space station, 6 hooks at a time. This will take a few minutes to complete.
That's right, that MCS is just configuring the International Space Station's attitude control. It needed to be configured differently between a soft capture and hard capture sequence. So now that that's been confirmed, they can go ahead and press to drive the 12 hooks needed to confirm a hard capture. To reiterate, the Dragon had contact and capture with the space station at 2:08 a.m. Pacific time, 5:08 a.m. Eastern. Space Station and Dragon crossing over the Terminator line just south of Australia, about to head over the South Pacific Ocean. Start seeing the views of Dragon get a little bit dimmer as we still undergo the hard capture sequence. All right, again, we're still undergoing the hard capture sequence. There's 12 hooks that drive to officially mate Dragon to the International Space Station, 6 of them driving currently. Station attitude configured to support the hard capture sequence, now operating on control moment gyros to maintain attitude control during the hard capture sequence. All right, and we have confirmation the first set of hooks, all 6 have been driven. They look good. The second set are driving and are looking good at the anticipated speed. Halfway there.
This will take just a couple more minutes for hard capture to complete. As a reminder, after hard capture is complete, they do still have some more steps that they need to go through in order to ensure that the space station and Dragon are safe for crew ingress. There will be the hatch opening as the crew the crew on board Dragon as well as the station will be walking through some procedures prior to ingress of the Crew-2 crew on the International Space Station. But once they do ingress on the station, there will be a welcome ceremony.
Again, half of the hard capture hooks have been driven and locked into place. The second set of 6 hooks, 12 total, 6 of them driving.
Dragon, SpaceX on the big loop. Hard capture is complete. You are go to open visors.
Copy, hard capture complete. Opening visors.
All right. Crew Dragon Endeavour officially made it to the International Space Station. That dynamic period of the docking phase is complete. The crew inside Dragon have been wearing their suits just as an extra precaution, but they can go ahead and pull up their visors. It's going to be some time until the hatches themselves are open between Dragon and the International Space Station. Still some things to configure on that side. The vestibule on the International Docking Adapter that separates the hatches of Dragon and the International Space Station. That's been exposed to the vacuum of space and has had the sun shining on it periodically. So when repressurizing the vestibule to equal the pressure inside the space station.
Station, hard capture complete. Welcome to ISS. We are so excited to have you aboard.
Thanks, Shannon. We're glad to be here. We'll see you all in a few minutes.
International Space Station Commander Shannon Walker welcoming the crew. Now Crew-2 officially made it to the International Space Station. Again, it's going to be some time until they come in, but the commander of the International Space Station welcoming 4 new crew members for her expedition on board here shortly. All right, so again, there's a series of steps here as we enter into an orbital nighttime, completing the docking of Crew Dragon Endeavour to the International Space Station for a second time. That contact and capture occurring at 2:08 a.m. Pacific time, 5:08 a.m. Eastern. We have a confirmed hard capture. The umbilical is in motion to connect the station to the Dragon and provide data and power and communication through that umbilical, so it no longer has to rely on its own systems. Everything's looking good for that vehicle. It's going to be some time again until we repressurize the vestibule and get those hatches open between the Dragon and the International Space Station. It'll be the crew inside the station getting that ready to be opened.
Endeavour, SpaceX, docking sequence is complete. Welcome to the ISS.
Thank you, SpaceX. Great to be here.
In some more official words, that docking is complete. The crew must be so excited to finally have arrived at the space station. Again, there is some more steps that they will need to complete and some checks before they can ingress on the space station. But the crew can now get out of their suits before moving into hatch operations. So now they can start to get comfortable again. They no longer need these suits now that they have arrived at the space station.
That's right. And so it'll be some time again until that area between the International Space Station and the hatches.
SpaceX Endeavour on Dragon to ground. Are you ready for us to begin suit doffing?
SpaceX copies. You are go to begin suit doffing and audio configuration. Procedure 4.012.
Copy, that's in work.
So again, it'll take some time. The crew will begin doffing or taking off their suits. It'll be some time to repressurize the vestibule. Station side, astronauts on the station side will configure the hatch, getting ready to open that up and welcome the crew inside the International Space Station. It was a pretty great docking. Everything happened right on cue and as expected. So it was a great to see Crew Dragon Endeavour dock to the International Space Station once again. We've enjoyed it from here in Mission Control Hawthorne, but to see how things turned out from the space station side of things as we work together to complete today's operation, let's go to Courtney Beasley for a refresher on what's ahead now that Dragon is docked.
SpaceX cameras are external.
Copy, thanks.
Thanks, Gary. It's great to see Dragon successfully docked to the International Space Station. Even through the face masks, you can see and feel the excitement in the room here in Mission Control Houston. Now that we're docked, Victor Glover is securing some hardware, and then he'll move right into hatch operations. First, he will open the large hatch at Node 2 forward, giving him access inside the pressurized mating adapter. Then he will have to pressurize the vestibule, which is the small space between the hatches on Dragon and the space station. This was exposed to vacuum prior to docking, and he will need to fill it with air and make sure its pressure is nearly equal with the atmospheric pressures on Dragon and the station. He will use a small valve on the station's hatch to slowly introduce air into the vestibule, and flight controllers here in Houston will monitor the pressure and temperature readings inside and verify that everything is leak-free before we get ready to open up the hatches. We expect it to take about 2 hours to get everything pressurized and checked out before we open hatches. With Dragon successfully docked to the International Space Station, that's the latest from here in Mission Control Houston. And back to the team over in Hawthorne.
All right, thanks, Courtney. As mentioned, it will take some time to go ahead and go through those procedures, but we'll stay with you throughout today's coverage. Of course, one of the major things will be repressurizing the vestibule in between the hatches. There's a hatch called the A-Pass hatch. That's the hatch on the International Space Station side. And then there's the Dragon hatch itself. In between is a vestibule that's currently at vacuum. So in order to travel through both hatches, you need to repressurize that. Now that there's a hard mate between the two vehicles, they'll check the seal. They'll do some leak checks as they're repressurizing the vestibule up to vacuum. And that will take some time.
SpaceX Endeavour, com check on the cabin mic.
SpaceX has you loud and clear on the cabin mic.
We have you the same, thanks.
You're hearing the crew inside Endeavour go through their procedures. One of the first things they're ready to do is take off those suits. They had to wear it through several of the operations of a launch from the Kennedy Space Center to a docking with the International Space Station. Launch is a very dynamic activity, so they had suits on up until orbital insertion, and then they were able to doff their suits, have a meal, go to bed, check out some of the systems, wake up, and then right before they entered into the approach phase of today's flight with the approach initiation burn, they got their suits on and were able to pressurize them, and they held pressure throughout that sequence of today's flight until docking. Now they get to take it off, they get to stretch out, change into something a little bit more comfortable, but not too comfortable, of course, because they will be, we will have an event to welcome them on board the International Space Station we expect all 11 crew members to be there to welcome them. It's going to be pretty crowded, but it should be very exciting to see that many people on board the International Space Station.
And those call-outs that we just heard they were doing a comm check with the Crew Dragon communications because they've now taken off their suits. They have comms through their suits, but since they're not going to be wearing their suits anymore, they need to use the comms through Dragon. So very exciting. It sounds like they're getting out of their suits as we speak, or doffing their suits. And then we will soon begin the process to open up those hatches so that the crew can finally ingress onto the space station. So it will take a little bit of time, but we will be here with you through every step of the way. If you're just now joining us, the Crew-2 crew has finally docked to the International Space Station after an approximately 23-hour ride from Earth to the station. Again, they are going to be performing a few procedures here before the Crew-2 can ingress onto the space station. They will be opening the APAS hatch, which is the space station side hatch, followed by the Dragon hatch. But this will take some time. They will need to repressurize the vestibule in between those two hatches before the crew can ingress.
That's right. The umbilical on the Dragon side has been fully extended to provide power, communications, and data from the International Space Station to the Dragon, so the Dragon no longer needing to rely on its own power systems. And of course, when the hatches are open, they'll be able to mix the air from the environment that's inside the space station with the Dragon, so it no longer needs to rely on its environmental control and life support systems. In the meantime, it is still doing so because the hatches are closed between both the Dragon and the International Space Station. There is a gap called the vestibule in between them that's currently at vacuum. That vestibule has been exposed to the vacuum of space on the forward end of the International Docking Adapter. So when bringing the pressure back up, there may be swings. Because of the temperature variation, there may be swings that need to dampen out before an effective leak check could take place. So the process of repressurizing the vestibule in between those two hatches does take quite a long time. It's expected to be about 2 hours until both of the hatches are open because of the length of time of repressuring that vestibule. Now from the station side, Victor Glover will outfit the A-Pass hatch. That's the one on the station side. He'll open it up and remove, once the vestibule is pressurized, he'll open that up and remove the docking target and install some padding onto the A-Pass hatch so that there's no unnecessary contact as astronauts are coming through the hatch from Crew Dragon to come inside of the forward end of the International Space Station.
Station Houston on 2 on the big loop. You are go to pick up in ingress part 1, step 1. Note that the pre-ingress ventilation in step 1.6 is not required.
Okay, picking up step 1 and 1.6 not required.
Dragon SpaceX, no response required, but ISS power connection has been established.
There you go. So Victor Glover on the International Space Station side already going through his procedures to get the hatches configured for ingress, essentially supporting the opening of the hatches, repressurizing in the vestibule. There's a lot to happen before we can open up the hatch and welcome the crew on the inside. The umbilical has been fully extended, and we just got confirmation that Dragon is drawing power from the International Space Station, so the solar arrays on the station providing power downstream to the Dragon. Dragon no longer needing to rely on its power. That officially confirmed. It will again take some time until the Dragon hatches are open. Dragon and Space Station hatches are open. And we've noticed for the past 2 times that Crew Dragons have docked to the station. The past 2 times being when Crew was aboard for Demo 2 and for Crew 1. We did notice that the crew inside Dragon took some time before to get themselves situated, make sure everything on the Dragon side was configured before they left it and entered into the International Space Station. We should see celebratory hugs from the crew on board as they make their way one at a time, as they'll be together for the next few days until they have to say farewell to the Crew 1 astronauts aboard the International Space Station. Shannon Walker handing over command of the International Space Station. Before she does that, she's going to hand command over to Aki Hoshide, who's currently on board Crew-2. He'll take the responsibility of International Space Station commander through the duration of Expedition 65 until he's ready to hand it off to the next crew. That all happening in the next couple of days.
Crew Dragon Endeavour is docked to the International Space Station as we speak. The crew on board the space station as well as Crew-2 are preparing for a couple procedures here for hatch opening. That is the hatch opening on the space station side as well as the Crew Dragon hatch. And this will take approximately an hour, a little over an hour and a half to walk through all of these procedures. So though Crew-2 is at...
Station on the big loop, node 2, forward hatch is open.
And Ike, we copy, and you are go to continue through step 2, pressurizing vestibule.
Continue through step 2.
As I mentioned, they are walking through several procedures to get those 2 hatches open As you can hear, that communication between Victor Glover on board the station with the ground team helping him out with the procedures.
That first hatch that he mentioned is the Node 2 forward hatch. From inside the Node 2 segment of the International Space Station, there are 3 hatches to get from Node 2 all the way down to the Dragon itself.
Dragon SpaceX. If desired, reference procedure 4.400 for monitoring vestibule pressurization.
Copy 4.400 for vestibule depress.
So now that Node 2 forward hatch is open, Victor Glover inside the pressurized mating adapter. Down the PMA is the APAS hatch, the hatch that separates the International Space Station now from the Dragon. With the Node 2 forward hatch open, Victor Glover can work to manually pressurize the vestibule. And we just heard from here in Mission Control Hawthorne that the crew on board Dragon Endeavour will be able to monitor the vestibule pressurization on their displays from the side of the Crew Dragon. You're getting a live look at both of the flight control rooms.
On the big loop. APAS equalization valve closed at 0938.
Houston copies 0938.
So you're looking at both of the flight control rooms on the left. SpaceX headquarters in Hawthorne, California. Flight controllers there successfully monitoring the navigation of Crew Dragon Endeavour that autonomously made its way from the Kennedy Space Center in Florida to the International Space Station, docking at 2:08 a.m. Pacific time, 5:08 a.m. Eastern. With the International Space Station as they've been flying over the South Indian Ocean. The control teams are now working to configure Dragon for its stay aboard the International Space Station. They've hard mated it using 12 hooks that drive to connect it to the International Docking Adapter, and have connected an umbilical and confirmed that power is being drawn from the space station to the Dragon, Dragon no longer needing to rely on its power source during its stay. All right, if you're just joining us, you're getting a live view of both of the control rooms. On the left is SpaceX Mission Control in Hawthorne, and on the right, Mission Control Houston with the International Space Station Flight Control Room. Crew Dragon Endeavour is officially docked to the International Space Station, and right now teams on both the station side and Dragon side are working to get ready to open up the hatches in between them. It's going to take some time until we get to that point where we're able to open up the hatches. Victor Glover on the station side is currently inside the pressurized mating adapter. He's working to manually pressurize the vestibule that exists between both of the hatches. It's going to take some time because that vestibule has been exposed to vacuum since before Crew Dragon just docked at 2:08 a.m. Pacific time, 5:08 a.m. Eastern time. And because it has been exposed to vacuum, the thermal environment causes it to have a little bit of oscillation as the pressure is rising. So they need to have some thermal equalization in the vestibule before beginning the pressurization to ensure that the leak checks are accurate. So they'll do a leak check on the way up to pressure, which is a little more than 14 pounds per square inch. They'll do a pressure check at 5 pounds per square inch, make sure everything's good, that the vestibule is holding pressure, and then they'll continue on up to match the pressure between the International Space Station and the Crew Dragon. In the meantime, Victor Glover will open up the A-Pass hatch on the International Space Station side. That's the hatch that separates the vestibule from the Dragon hatch. He'll outfit the A-Pass hatch by taking off the docking target, which is a long rod with an X on it, and was used for some of the optical navigation equipment on the Crew Dragon for Dragon's approach and eventual docking to the station. He'll remove that, he'll put some pads on the A-Pass hatch, make sure no one bumps their head on the way in. And then when he heads into the vestibule, there is a little window. Hopefully he'll be able to wave to his crewmates before they actually open up the hatch of the Dragon itself. After both hatches are open, the crews on both sides will get positioned. Well, first the Crew-2 astronauts will just make sure everything is okay on the Endeavour side before they go ahead and officially leave that vehicle. Crew from inside Endeavour will enter or ingress into the International Space Station one at a time, being greeted by the 7 crew members that are currently aboard the International Space Station, including Crew-1 astronauts. You have Mike Hopkins, Victor Glover, and Shannon Walker from NASA, and Soichi Noguchi from the Japan Aerospace Exploration Agency. Also on board, arriving on a Russian Soyuz in April, earlier this month, was Mark Vande Hei of NASA and Oleg Novitsky and Pyotr Dubrov from Roscosmos.
Dragon SpaceX for audio configuration.
Go ahead for audio config.
Shane, we are about to transition to hardline audio with ISS.
Copy.
All right, so you just heard the confirmation. The Dragon and International Space Station are mated now by not only the International Docking Adapter, but there is an umbilical that's extending to the space station. We did have confirmation that we have power that's being drawn from the space station to the Dragon side, so they're configuring some of the other channels, including communication. So they'll configure that one at a time. Some of the sequence of events that's going to happen over the next couple of hours until as we continue to repressurize the vestibule and get the station and Dragon outfitted to eventually open up the hatches. We'll be with you throughout the entire duration of this sequence until we have those hatches open and provide a live coverage of a welcome ceremony, show the inside of the space station and the crews of Dragon, both Resilience and Endeavour, and of course the MS-18 Soyuz vehicle that are all on board the International Space Station now as part of Expedition 65, welcoming each other officially aboard.
and Endeavour Houston on 2 on the big loop for hardline. We are ready for comm checks with SpaceX, ISS, and Houston.
All right, so it's a little hard to see from this view. It's a external camera view aboard the International Space Station. On the port truss, you can sort of see the nose cone flipped up, but that's Crew Dragon Endeavour on the forward end of the station. It's hard mated using 12 hooks that have driven to hard capture Crew Dragon Endeavour to the International Space Station. It's also connected by umbilical to the station. We've confirmed that power is being drawn from the station to Dragon. Dragon no longer needing to rely on its own internal systems for power. That umbilical also provides a communication line. Now coming up will be a test of that communication line between the teams, between the Dragon itself, Crew Dragon Endeavour, and the International Space Station, and the ground teams, making sure that that connection that we've been hearing throughout the approach and docking phase of today's flight on the big loop.
SpaceX Houston in station. This is Endeavour. Comm check.
And SpaceX has you loud and clear, Endeavour.
And Houston has you loud and clear.
And the space station has you loud and clear on hardline.
We copy it all on hardline. Loud and clear.
All right, so the same control teams that we've been hearing through the approach and docking phase of the flight on the big loop. That includes the SpaceX flight controllers in Mission Control Hawthorne. The voice you're hearing is Core or Crew Operations and Resource Engineer Arthur Berrialt. He confirmed from here in Hawthorne. From Mission Control Houston, Capcom Kathy Bolt confirmed the hardline communication network is working on board the International Space Station. That was the voice of Victor Glover, who's currently working through the procedures for opening up the hatches, including the repressurization of the vestibule. Still awaiting some temperature equalization there before that begins. But that'll be some of his next steps. And then aboard Crew Dragon Endeavour, Commander Shane Kimbrough confirming that hardline communication is working. So we got good power and good communication through the umbilical line to the Dragon from the International Space Station. We'll continue to provide periodic updates throughout this sequence of repressurizing the vestibule and opening up the hatches, configuring the Dragon and the International Space Station as they are mated together in space.
SpaceX Endeavor for some reports on 4.400 when you're ready.
SpaceX is ready to copy for 4.400.
Okay, for tablet percentage MS1 77, CDR 84, PLT 87, MS2 79.
All right, SpaceX copies. Reading back. Tablet power is MS1 77, CDR is 84, PLT is 87, and MS2 is 79.
Good readback.
Station Houston on 2. We've had a good vestibule pressurization and leak check. You are go to pick up and ingress part 2, step 3.
All right, that's great news. Picking up in part 2, step 3 for ingress. Thanks.
Us, you are watching the live broadcast for the Crew-2 mission for SpaceX and NASA. The Crew-2 Dragon Endeavour has docked to the International Space Station. They're currently working some procedures to process opening the APAS hatch, which is the hatch on the International Space Station side, as well as the hatch on the Dragon, Crew Dragon, prior to crew ingress onto the space station. And what you're looking at on your screen is Crew Dragon Endeavour docked to the International Space Station. We are hearing some call-outs as they're walking through some procedures, so we're keeping up with the teams. Again, this process does take a bit of time.
So if you're just joining us, the Dragon itself is attached to the International Space Station. The crew inside, namely Victor Glover, is making incremental steps to open up the hatches between the International Space Station and the Dragon itself. Glover waited for thermal equalization of the vestibule in between each of the hatches, the station side and the Dragon side. After thermal equalization, he brought it up to about 5 pounds per square inch, performed a leak check, and everything looked good, so he proceeded to increase the vestibule pressure to equalize with the International Space Station's pressure. With vestibule pressurization complete, and after a few checks, Glover will be given the go to open up the station side hatch, the APAS hatch. Once that's open, he'll be able to see the Crew-2 astronauts inside the Dragon Endeavour. There's a small window on the Dragon hatch that he'll be able to see them. And his main job before opening up that hatch will be configuring the station side hatch. That hatch is configured with a docking target. It's a small rod with an X on the end that provided guidance for the Dragon during its approach to dock with the International Space Station. He'll remove that docking target and provide some padding to allow a safe entry into the International Space Station for the Crew-2 astronauts.
Victor Glover is one of the NASA astronauts that flew on Crew-1 about 6 months ago. So he is the one preparing, who has been preparing the space station for Crew-2's arrival. This is Victor's first mission on the International Space Station, and first time that he has been to space, so it's pretty cool that he gets to welcome the Crew-2 team and help get them on board the space station.
And Station Houston on 2 for Node 2 video.
Go.
Yeah, we were wondering if we could get permission to come on board in Node 2.
You're welcome. Please come on board.
Okay, and we'll need the high-def camera powered on.
All right, so we've been very lucky with some of the external views here. This coming from a camera on the Japanese exposed facility pointing at the forward end of the International Space Station where the Dragon is currently docked. Crew Dragon Endeavour. Very shortly, with permission from Victor Glover, we should be getting some views from the inside of the International Space Station and seeing what Victor Glover is up to. He's at the forward end, inside the pressurized mating adapter, going through his procedures to configure the APAS hatch, getting it ready to open. We did hear confirmation earlier that the vestibule is pressurized between the two hatches, those hatches being the station hatch and the Dragon hatch.
Looks like we got that live view on the station.
I think that's Soichi Noguchi on board the International Space Station. Colonel Mike Hopkins, NASA astronaut and commander of the Crew-1 Dragon Resilience, coming into frame as well. There are 7 crew members currently aboard the International Space Station, not counting the Crew-2 astronauts who are on the other side of that hatch. Once that hatch is open, there will be 11 crew members on board the International Space Station. Sort of forget that you don't really need to be in an upright position to work from this orientation. We're looking sort of in an upright position. If you look down or nadir from this position, you would go straight down towards the Earth, but you can see clearly Soichi Noguchi upside down. Mike Hopkins was just upside down. You don't really need to be in a particular orientation to work.
Coming into frame, that is Victor Glover.
And there's Mark Vandehei from NASA, who arrived earlier this month on the Soyuz MS-18 rocket launching from Kazakhstan, with 2 Russian cosmonauts, Oleg Novitsky and Pyotr Dubrov. They'll be joining for the welcome ceremony to welcome the Crew-2 astronauts aboard as well.
Another thing to point out, you could see that each of them are just wearing socks. Don't really need shoes to be on the space station, since they're not really walking anywhere. They're floating around.
Yeah, they use their hands really to propel themselves from module to module, but their feet, you can see some of the blue handrails situated around the International Space Station. Ooh, there's a good shot of how astronauts typically use those handrails. They'll wrap their feet underneath them to stabilize them. Looks like the pressurized mating adapter is used for some stowage. So there's looks like Noguchi and Glover are reconfiguring some of the stowed items to allow some room to open up the A-Pass hatch, the hatch on the International Space Station side, and provide a pathway for the Crew-2 astronauts to come through the hatch to be welcomed in Node 2. So again, the vestibule is pressurized between the Dragon hatch and the station hatch. You can see Noguchi working on the station hatch. His next procedure is to go ahead and open it. And you can see, confirmed, A-Pass hatch is open. Noguchi taking some initial photographs. Part of the procedures will be to survey the hatch itself, inspect for any foreign object debris.
Houston Station, Big Loop, A-Pass hatch open, and that's dry, and seals are clean.
And Houston copies, and you can continue in step 4.
Dragon, SpaceX for procedure 4.400.
Go ahead, SpaceX.
All right, Shane, when you're ready with that A-Pass hatch call, that does unblock us to go into section 5 of 4.400 when we get there. Additionally, when you're ready, we are ready to collect inventory in section 3.
Okay, inventory coming to you, and we're ready for section 5 after that.
SpaceX copies, thanks.
Hey, Arthur, Thomas for the inventory. So just quickly compared to what I reported prior, the only delta is 2 bottles from location, from bag 204 in location 9. All the rest is as per our previous report. So I'm not sure you need all the details of what's remaining, because I kind of gave the detail of what we've consumed from the food locations. I can give you the details, it's your call.
SpaceX copies. If there's no delta from your previous report, we don't need it, but I will read back. That was 4 bottles from bag 204.
Two bottles, Arthur, 2.
Copy that. 2 bottles from 204. Last question for section 5 of 4.400. Does that 2 bottle include the additional bottle that will be used in step 5.1, or will we require an additional bottle?
I know it's a good question, Arthur, and we're working on this, so you can add another bottle for this section, and we'll grab it from 206.
All right, SpaceX copies. Thanks, Tama. We'll take one bottle from 206. And Tama, SpaceX, last question. Can you confirm no food deltas from previous report, or did you also consume midday meals for today?
No, we didn't consume anything. The latest, last food consumption was the one I reported before.
All right, copy. Thank you.
All right, you just heard the core here in Mission Control Hawthorne communicating with the crew on the inside of the Dragon. They're behind this camera view that you're seeing here. This is the center line camera of Crew Dragon Endeavour. You're getting a look at Soichi Noguchi as he outfits the APAS hatch, getting ready for the astronauts inside Endeavour to come through the hatch. The hatch to Dragon is still closed as Noguchi continues to outfit that APAS hatch. He took some photographs upon entering into the vestibule that you see here and took some photographs to survey the APAS hatch, make sure the seals look good, reported that they all looked good, so he's continuing with the procedures to attach some pads and remove the docking rod from the center of the APAS hatch. APAS standing for Androgynous Peripheral Assembly System. It's just the hatch on the station side, the last one until you get to the Dragon hatch.
Dragon SpaceX, question on procedure 4.012, suit doffing.
Go ahead, SpaceX.
All right, Shane, just wanted to follow up. We wanted to confirm that all 4 suits are drying, and then when ready, when we can come back on board.
All 4 suits are drying. Some of them have been drying for an hour already, and you are welcome to come back on board.
Copy that, Tama. Thank you.
Very cool. Got some words that we might get some camera views inside of Crew Dragon with the Crew-2 team already doffed their suits, confirming that their suits are drying as they are waiting for ingress on the International Space Station. What you're seeing on your screen is Soichi Noguchi getting this vestibule area set up for the Crew-2 ingress prior to opening the Crew Dragon hatch. Once that hatch is open, the crew will not immediately ingress onto the space station. They do need to follow a few more procedures just to make sure that everything is good to go before they ingress on the space station.
So you see some of the padding that's needed to outfit that APAS hatch. He's just wrapping it around the metal structure that is the station side hatch. He'll do this to completion. On the other end, we'll hopefully be getting some views from the inside of the Dragon cabin and seeing both perspectives from the Dragon side.
Dragon SpaceX, for awareness, cameras are back on board.
Thanks, welcome on board.
All right, we'll hopefully get those views inside Dragon soon. Meanwhile, Soichi Noguchi continuing to outfit the hatch. Again, this is one of those steps to get all of the hatches open in between Dragon and the International Space Station. Now getting views from inside Dragon. The crew have doffed or taken off their suits. And so now they're dressed and ready for the welcome ceremony. Once they get on board, we'll have some hugs, and they'll have a chance to talk with some of their crewmates before getting in front of the camera to officially welcome the Crew-2 astronauts aboard the International Space Station, an orbiting complex that will support a crew of 11 until Wednesday the 28th is the planned undocking time for the Crew-1 astronauts, Soichi Noguchi, currently one of those astronauts that will be departing, along with 3 American astronauts, including Shane Kim, Mike Hopkins, Shannon Walker, and Victor Glover. All right, looks like Noguchi has that APAS hatch wrapped. You can see just above him, he used a series of padding and blankets to wrap the metal structure that is the station side hatch, and now he's inside the vestibule. See some of the tubes he's bringing in the vestibule section that are peeking through towards us on the pressurized mating adapter side. That'll allow the circulation of some of the air from the station side and remove any carbon pockets that may appear in the environment of the space station. So we're a little more than an hour and a half removed from the docking, the official docking
Houston,
time.
Hawthorne Endeavour Station is ready for Dragon Hatch equalization.
Houston, copy.
Endeavour copies.
Endeavour copies.
NASA astronaut Mark Vande Hei coming in to help out. The crew on both sides getting confirmation. The next step's underway to get that other hatch open. There's one more hatch. You see the station side hatch open at the back end of the pressurized mating adapter there. There's one more hatch, the Dragon, on the Dragon side. And the crews on both ends are working through to open up that hatch and welcome the Crew-2 astronauts on board. Just going to stand by for a few minutes for pressure to equalize between the International Space Station and the Dragon hatch before go ahead and opening that final one.
And Endeavour Houston, can you confirm readiness for hatch equalization?
Endeavour's ready. Endeavour's ready.
Okay, station and Endeavour, stand by for equalization. It's expected to take 5.5 minutes.
station, copy.
Endeavor copies. Endeavor copies.
All right, so you heard that equalization time. A timer is set for about 5.5 minutes to allow that pressure to equalize between the pressure inside the environment of the International Space Station and the pressure inside the Dragon. That pressure has to be equalized within both spacecraft before the Dragon hatch is open, one of the steps to open up that final hatch. So we'll just stand by as that equalization is underway. In the meantime, you can see in the pressurized mating adapter, Mark Vande Hei currently moving some stowed iguns around, creating a clear pathway for the Crew-2 astronauts to enter the International Space Station once they head through the hatch, being assisted by Suichi Noguchi. We've also seen Victor Glover, who was primed for monitoring Crew Dragon's approach to the International Space Station. So it looks like Glover is resetting the camera position there. That view provided a nice angle downward into the pressurized mating adapter to see some of the activities happening for opening up the hatches. Now Glover's just getting that camera set up for the next activity, which will be a welcome ceremony. Putting it in a good position to frame or allow to frame 11 astronauts to squeeze into that shot. I think that'll be a impressive feat by itself.
Yeah, that is quite a bit of people, especially for the International Space Station. But it'll be really cool to see them all together.
So right now it's looking like the procedures to undergo opening up the hatch. Again, we're still waiting for pressure to equalize between the space station and the Dragon itself before opening up that hatch. But it seems like we're on a good timeline to start a welcome ceremony on time. That's expected to begin at 4:45 a.m. Pacific. Should be 7:45 a.m. Eastern. gathered inside Node 2. Now you see over to the left is NASA astronaut Mark Vande Hei. Going from left to right, we have Crew Dragon Resilience Commander Mike Hopkins, followed by Soichi Noguchi and International Space Station Commander and NASA astronaut Shannon Walker. How do you fit 11 people on camera? That's what we want to know.
And that's what it looked like they were trying
That's
to
right.
figure out. Trying to get into position to see probably where that camera should be and where they should be facing.
Yeah. All right, we'll get periodic handovers from the views we were seeing on board the International Space Station as well as Dragon. The views being provided through tracking and data relay satellites, geosynchronous satellites that provide that video feed from the International Space Station. Right now you're looking at mission control in Hawthorne, flight controllers looking after the Dragon Endeavour and its systems. Dragon will be configured for a long duration stay aboard the International Space Station, eventually being configured for a quiescent mode. Will remain there for 6 months with periodic checks, of course, to check on the status and health of the spacecraft itself before it departs 6 months down the road.
And Endeavour and Station hatch equalization has started. 5.5 minutes wait time.
Endeavour copies. Station copies.
All right, so the pressure is... The equalization process has been started between the International Space Station and Crew Dragon Endeavour. The clock starts 5.5 minutes. After that clock runs out, the teams will verify that the hatch is good to open between the Dragon and the International Space Station. We're still tracking to start the welcome ceremony at 4:45 a.m. Pacific time, 7:45 a.m. Eastern. We'll hopefully get to see the crew in early, but they'll be able to do some hugs, get settled, and then get in position to start the welcome ceremony. We'll keep you up to date if that time does change, but it seems we're looking good so far for the Endeavour crew to enter into the International Space Station.
It looks like we got that live view back on the International Space Station where they are preparing for the Crew-2 to ingress and getting set up for that welcome ceremony. You can kind of see them all coordinating with each other on maybe where the cameras need to be. in where they want to do this welcome ceremony. We're currently waiting for equalization of pressure between the International Space Station and Crew Dragon prior to opening that hatch on the Crew Dragon.
So again, we're in the middle of a 5.5 minute timer as equalization is underway between the pressure inside the International Space Station and pressure inside the Crew Dragon Endeavour. So we'll just wait on the status after that 5.5 minute timer and the OK to open up the Dragon hatch. It may be some time after the Dragon hatch is open until the Crew-2 astronauts enter into the International Space Station. But we're tracking a welcome ceremony to formally begin as of now in 45 minutes. Keep you up to date in case that changes.
Looks like we just have a different camera view on the International Space Station. And that is JAXA astronaut Soichi Noguchi that you see in the frame right now.
Preparations happening on both sides. We're mostly getting views from the International Space Station side, but the Crew-2 astronauts are inside the Crew Dragon capsule getting configured. Because once they enter through the hatch, they'll join the 7-member crew of Expedition 65 that's currently aboard the International Space Station and conduct a welcome ceremony. We'll see some hugs and shared camaraderie among the Expedition 65 crew for a little bit, and then formally welcome them to the to Expedition 65 aboard the space station.
Dragon SpaceX for 4.400.
Go ahead, SpaceX, on Dragon to ground.
Hey Shane, just looking for confirmation of completion of section 5 of 4.400.
Section Houston 5 is complete.
SpaceX copies, thanks. And additionally, last check is completion of procedure 4.012, suit doffing.
Yeah, sorry, we didn't let you know that. 4.012 is complete.
Much appreciated. Thank you, Shane.
All right, a few checks from the crew operations and resource engineer.
Dragon SpaceX on the big loop for hatch open.
Go ahead for hatch open on the big loop.
All right, Dragon, you are go for hatch opening per the decal on the hatch, followed by the remaining actions in procedure 4.400, section 6.
Okay, that's in work.
Good words that they got the go for opening the Dragon hatch.
It's fantastic news. We can kind of see the hatch from this angle. Hopefully it remains unobstructed. We may be able to see the, yep, you can see the handles moving a little bit. Yes, there it goes.
Again, this is being opened from the interior side of the Crew Dragon vehicle. So this is the Crew-2 crew performing this work right now. It looks like the crew on station is getting excited, peeking in.
I can feel the energy for sure. All right, Dragon hatch is open.
Already seeing a bunch of smiles.
All right, that Dragon hatch, the final hatch that we've been waiting for since Endeavour docked to the International Space Station 2 hours ago, 2:08 a.m. Pacific. 4:05 a.m. Pacific is the time that Dragon hatch was open. Already seeing some smiles.
So again, as we mentioned, the Dragon hatch is open, but the Crew-2 members still need to finish walking through some remaining procedures before they can ingress onto the space station, including photos. It looks like you can see the the crew posing for some pictures there.
SpaceX on the big loop, hatch is open.
SpaceX copies on the big loop. Hatch is open.
All right, again, the hatch was open at 4:05 a.m. Pacific. The space station and Dragon flying together in unison. Attached, Endeavour attached at the forward port. Those vehicles were 267 statute miles over the South Pacific to the east of New Zealand.
SpaceX Endeavour 4.400 complete.
SpaceX copies. 4.400 is complete.
So as a reminder, even though the Dragon hatch is open, it still may be a couple of minutes until the crew, Dragon Endeavour astronauts actually ingress or enter into the International Space Station to be welcomed by all of the expedition's 65 crew members currently aboard who are eagerly awaiting them to come on board their new home, the International Space Station, for the next 6 months. There's a couple of procedures. You see some of the air ducts.
And Houston Dragon in 2.102, step 6, 1 IMV duct installation complete. You are go for IMV fan activation.
Houston copies. We'll put that in work.
Okay, yeah, so some of those procedures that are happening on the Dragon side, they're going to install some IMV ducting, mixing the air of the International Space Station environment with the air inside the Crew Dragon Endeavour. They're going to seal some of the LiO, or lithium hydroxide cartridges that scrubbed carbon dioxide inside the Dragon capsule on the ride up to the International Space Station. They're going to check some vent valves, so it may be some time until we actually see them welcomed aboard. But just these last final checks are critical before they leave the capsule that brought them up to the International Space Station. Make sure it's good to go, because it will remain docked here for the next 6 months.
Looks like the station side crew is ready, and they're just waiting for the Crew-2 crew to ingress onto the space station here in a few minutes once they finish their procedures. And lots of smiles. They look very excited for this right now. If you're just now joining us, the Crew-2 Dragon Endeavour is attached to the International Space Station. We are just eagerly awaiting the crew on board Dragon to ingress onto the space station here shortly. They're finishing their final procedures. Both the APAS hatch and the Dragon hatch are open. So we should just be a few minutes away from the Crew-2 astronauts ingressing onto the space station.
Meanwhile, in the frame now, you can see the 4-person crew of Crew Dragon Resilience. From left to right, you have Victor Glover, Shannon Walker, Soichi Noguchi, and Mike Hopkins.
And Soichi doing some flips for us.
That's right.
This is the Crew-1 crew waiting to welcome the Crew-2 crew, whom they will hand the baton off to. They'll spend approximately 5 days with the Crew-2 astronauts as they do a handover prior to Crew-1 coming back to Earth as early as April 28th next week.
Endeavour Houston, you are go and step 6.3.
You go and 6.3 for Endeavour. 6.3 for Endeavour.
We got some communications from Houston to the Crew-2 members on board Dragon. Continuing with the next procedure. Again, they should be ingressing on the International Space Station here very shortly. Crew-1 crew hanging out on your screen there, waiting for Crew-2 to ingress.
Again, all the hatches are open between the International Space Station and Dragon. The crew of Endeavour just going through some last-minute checklists to make sure that Dragon Endeavour is configured properly before they leave it, which successfully carried them from the Kennedy Space Center in Florida to the International Space Station over the course of just a little more than 23 hours. Docking with the space station earlier this morning at 2:08 a.m. Pacific. Coming into frame here, you see at the forefront of the frame is NASA astronaut Mark Vande Hei joining the Crew-1 astronauts. All of them currently members of Expedition 65. It's part of their mission to stay on board the International Space Station for a long-duration mission of science, maintenance, technology demonstrations, and upgrades.
If you're just now joining, you are watching the live broadcast for the Crew-2 mission. We are currently waiting upon the ingress of the Crew-2 astronauts onto the International Space Station. They have already docked. Both the A-Pass hatch and the Dragon hatch are open.
New to the frame on the left there is Roscosmos cosmonaut Oleg Novitsky. He was the commander of the MS-18 Soyuz spacecraft that made its way to the International Space Station earlier this month with NASA astronaut Mark Vande Hei. Also on board is Pyotr Dubrov, who hasn't been in front of the frame yet, but he'll be part of the welcome ceremony as part of the 11-member crew that makes up Expedition 65, currently aboard the space station.
Station Houston on 2. Station Houston on 2. We're seeing and voice check for upcoming PAO event. We're good with the scene check. If we could just get a voice check. And Shannon, we are not picking up any audio.
How about now? Having things on works better. 1, 2, 3, 4, 5.
And Shannon, we did hear you that time. We're checking. And Shannon, can you give us another long count?
Sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Copy, thank you. We're checking. And that's a good voice check.
and SpaceX Endeavour on space ground for LIO.
SpaceX is with you on space to ground for LIO.
We were trying to install the LIO with the bag cover, that is LIO 1, correction. Yeah, LIO 2, in the bag and in the non-active storage area. And while we were pushing in, it tore the bag, and it cut that bag pretty big. Would you like us to proceed with this or go without the bag?
Copy that.
Just to let you know, the seal is on that LIO cartridge too.
Copy that, Dragon. Just to read back, there's a tear in the LIO bag as a result of trying to insert into the LIO slot. Stand by, we're going to get you some forward actions.
Okay, copy. And we do have a camera pointing at it right now. It's a positive camera.
Copy that, we see it, thanks. Dragon SpaceX, can you confirm if it is LIO cartridge 1 or LIO cartridge 2?
Yeah, the LIO cartridge 2 is in the bag. LIO cartridge 1 is secured in the active location with the seal on.
Copy that. Stand by 1. Dragon SpaceX, we are going to have you stow that LiO cartridge without a bag. How copy?
All right, for those of you joining, we're in a handover period with some of the tracking and data relay satellites, geosynchronous satellites that provide the video feeds we were seeing and enjoying from the International Space Station as we eagerly await the crew inside Endeavour to enter into the International Space Station. The Expedition 65 crew members, all 7 of them gathered inside of the station on the other end of the Dragon's hatch, eagerly awaiting for them to get inside. Flight controllers here in Mission Control Hawthorne just undergoing a series of checks, final steps really, for the astronauts inside Endeavour to undergo before they enter through the hatch and leave the capsule that brought them up to the International Space Station. Some of the LiO cartridges you're hearing are lithium hydroxide cartridges that scrub carbon dioxide from the environment of the Dragon Endeavour capsule. Now regaining some of those views. Once the 4-person crew of Endeavour comes onto the International Space Station, there will officially be 11 crew members on board as part of Expedition 65. We're still on track to start a welcome ceremony here in a little less than 15 minutes. We'll have representatives.
Dragon SpaceX, repeating a call. We did have a teacher's handover. Want to confirm that we will stow this cartridge without a LiO bag. We just want to verify that the seals are secure on each side of the LiO.
And just to verify, seals are secure on both LiO cartridges 1 and 2.
SpaceX copies. Thank you.
And SpaceX, please let us know what to do with the bag itself.
So from left to right inside the International Space Stations.
Dragon, SpaceX copies. We do want to save this bag so we can look at the RIP in the future. Stand by, we're going to get you words on where to store it.
And Endeavour copies.
Crew of Endeavour still working through those last-minute procedures. Again, LiO cartridges or lithium hydroxide cartridges that scrub carbon dioxide from the environment of inside Crew Dragon Endeavour. You're getting live views from the International Space Station side. From left to right, we have Roscosmos cosmonaut Oleg Novitsky, followed by International Space Station Commander and NASA astronaut Shannon Walker. coming down from the...
LIO bag. Sorry, could you repeat where to stow that bag?
Yes, stand by, Dragon. We are finding a good common bag to put it in for temporary stowage.
Okay, copy that. We'll just stow it for now.
Copy, Dragon. If possible, we can also put it in a trash bag in location 17. That would be bag 111.
Okay, copy. We'll get a trash bag from location 17, bag 111, and put it in there.
Okay, copy. That is bag 111, and that is actually location 18.
Location 18, bag 111.
In this frame, all 7 crew members of Expedition 65 currently on board the station gathered to welcome the Crew-2 astronauts aboard Endeavour. On the top left is NASA astronaut Victor Glover. You see Soichi Noguchi in the foreground on the right there. On the far right is NASA astronaut Mark Vandehei. Mike Hopkins is just behind Soichi Noguchi there. And Roscosmos cosmonaut Pyotr Dubrov is on the zenith or space-facing side, sort of the ceiling from this shot, all gathered and eagerly awaiting for the 4-person crew of Crew Dragon Endeavour to come on board.
Soichi Noguchi doing some backflips as they eagerly await the Crew-2 astronauts to ingress on to the International Space Station. The Crew-2 crew is finishing some final procedures. Once they complete all of those procedures on board Crew Dragon, they should be able to ingress on the International Space Station. And once they ingress, there will be some welcoming hugs and smiles, and then we will have an official welcome ceremony.
It's been a long journey for the 4-person crew of Endeavour. It took them 23 hours to make their way to dock to the International Space Station earlier this morning. That docking time at 2:08 a.m. Pacific. The Dragon hatch was opened at 4:05 a.m. Pacific. We're counting down to the Endeavour astronauts to enter into the International Space Station, and we'll begin a formal welcome ceremony to officially welcome Endeavour to the International Space Station, and we'll have representatives from the space agencies of the crew on board Endeavour, including NASA and the European Space Agency and the Japan Aerospace Exploration Agency, chiming in to congratulate the Crew-2 astronauts and the support teams that helped to get them to the orbiting laboratory today.
Houston Station on 2, unless anybody's opposed, we're going to progress with ingress.
Endeavour, welcome aboard. You are go to ingress.
Endeavour arriving.
Got some confirmation that the crew is go for ingress, and you can see Aki is the first to ingress onto the International Space Station.
And Gwyn.
And Gwyn.
Followed by Thomas Pesquet from the European Space Agency.
Lots of hugs and smiles right now.
Pilot Megan MacArthur of Crew-2 is next, being welcomed by the Expedition 65 crew members, and Shane Kimbrough bringing up the rear. The 11-person crew of Expedition 65 now together inside Node 2 of the International Space Station.
Though we can't even hear audio in there, you could really feel the excitement just by the looks on their faces, the hugs that they're giving. Now they're getting ready for this official welcome ceremony. You can see them getting into position. Let the
Tetris game of fitting 11 crew members into a single frame begin.
Right. 12. Gwyn.
Oh, that's right.
Station, this is Houston. Are you ready for the event?
Houston, this is Station. We are ready for the event.
Mr. Jurczyk, please call Station for a voice check.
Station, this is Steve Jerzik. How do you hear me?
Steve, we have you loud and clear. Welcome to the International Space Station.
Hey, man, it is awesome to see the 11 of you on station. It's incredible. Congratulations, Crew-2 on an amazing launch yesterday. Coming to Kennedy Space Center and watching launches never gets old. And seeing the pre-dawn launch yesterday was amazing. So congratulations. I also want to congratulate the NASA and SpaceX team for our third commercial crew mission in less than a year. A lot of firsts on this mission, including the first crew handover of commercial crew vehicle, and it was really cool during docking to see one Dragon docked on the Zenith port and the other Dragon coming in for docking. So it was amazing. April has been an amazing month and a really busy month for ISS, with Mark, Pieter, and Oleg launching to ISS. Kate and her Russian colleagues coming back. Crew-2 there, and now preparing for Crew-1 to come back. And I am really excited for all the research, technology development that is going to be able to be enabled on station with these regular crew rotations and having 4 crew up there consistently. It's not only important for advancing research technology development to benefit folks here on Earth, but also to prepare for Artemis and our return to the moon, and eventually preparing for human missions to Mars. So it's just an incredibly exciting time for ISS. You know, Shane, Megan, Aki, and Thomas, we thank Tomas. We thank you for everything you do for the agency, the country, and the world, and we look forward to an amazing expedition. Crew-1, you guys have had an amazing 6 months. Mike, Victor, Shannon, and Suichi, I've followed what you've done to upgrade the station and all the research and technology you've been able to accomplish. And just want to congratulate you on an amazing expedition. And we look forward to your return next week. So again, I'm just really excited for this new era for ISS and all that you all have and will be able to accomplish. So thank you.
Thank you, Steve. It is very exciting to have Crew-2 with us today, and so I'm not going to take up any time here. I'm just going to hand it over so we can get their thoughts.
Thanks, Shannon. Thanks, Steve. And on behalf of Crew-2, we are just so excited to be here. I'm very excited to be here. In some ways, it's been a long journey. In other ways, it's been a pretty quick one-year assignment flow. So it's taken a tremendous amount of work from a lot of different teams to get us here. We, of course, have our excellent training team at Johnson Space Center, also an outstanding training team from Hawthorne, and the entire ISS program and commercial crew program working together to get us here, of course, as well as along with our international partners. We're just really excited to be here and be part of this historic mission with the 2 Dragons on board. First reuse of a capsule, first reuse of a booster. It's just a tremendous achievement on behalf of our partner SpaceX. So I want to congratulate and thank them. And we're so excited to be here. We're ready to get to work. There's a lot of great science that I know we're going to be doing, and we're just excited to learn and get started. So thank you.
Thank you, Mr. Jerzik. We now welcome Associate Administrator Kathy Leaders to provide remarks. Ms. Leaders, please call station for a voice check.
Station, hi, this is Kathy Leaders. Do you hear me?
Kathy Leaders, do you hear me?
Kathy, we have you loud and clear.
Wow, you know, I just don't, I think I could see Endeavour approaching station maybe one more time, you know, near and dear to my heart to see that going on. And, you know, I think both Steve and Megan mentioned how amazing it was to see resilience there on the station. The folks, Crew-1 folks and the other parts of the ISS team, Mark, and you guys had the best view, but it was really cool seeing it from here on Earth. Like Steve talked about, wow, this is, and Megan too, we talk a lot about this being, and exploration being a team sport, and this mission so far has really exemplified that. You know, with our commercial partner, SpaceX, with our international partners, and with Thomas and Aki, and obviously Megan, you and Shane, you know, holding up on the NASA side here, and then our commercial crew and ISS teams. Congratulations to all of you. It's just been an amazing, amazing mission, and I know you guys are going to be doing some really great things. I've been here watching the folks here on station waiting for you, and I know you guys will be having a lot of fun together over this direct handover period, and with all of you on board, it's going to be a lot of fun for you, and getting ready for Crew-1 to come home. So I just wanted to really, from the bottom of my heart, say thank you. Thanks to all of you. Thanks to the whole team, the international, the commercial, you folks there on the space station now today safely, and looking forward to, like Steve said, seeing your accomplishments over the next 6 months. Thanks again.
Thank you, Kathy. Really appreciate your support.
Thank you, Ms. Leaders. We now welcome JAXA President Dr. Yamakawa Hiroshi. Dr. Yamakawa, please call station for a voice check.
Station, this is Yamakawa Hiroshi from Tsukuba. How do you hear me?
Dr. Yamakawa, we hear you loud and clear.
Well, thank you, Aki. Well, congratulations to all. I watched yesterday's launch on TV and really feel relieved by your safe arrival to the station now. In this tough situation around the world, I believe you have brought courage and hope for all of us. It is a great pleasure not only for me but also for Japan that 2 Japanese astronauts, Aki and Soichi, have boarded the operational spacecraft of the Crew Dragon twice in a row. This represents the many years of close cooperation on the International Space Station. I'm so happy to see both of you with big smiles today. And I understand that Aki advocates teamwork for this long-term mission, which comes from your experience in rugby football. The ISS is a symbol of international cooperation around the world, and we are looking forward to seeing you work as a team, build a scrum with all of the crew members from NASA, ESA, and Russia on board, and keep scoring tries to maximize outcome during your mission. Soichi, we wish you a safe return to the Earth. And Aki, good luck and enjoy your stay in space. 野口さん、地球で待ってます。星出さん、これから半年間頑張ってください。Thank you very much.
Thank you very much. It's an honor to be part of this team. We have a 11-person scrum right here, and with 4 countries representing. It's really an honor and privilege to fly on Crew-2 Dragon and get here. Thank you to all the people that worked very, very hard to prepare us and the vehicle. We got here safely, and now it's time to work here on board the International Space Station. And we look forward to working with everyone around the world. Thank you very much.
Thank you, Dr. Yamakawa. We now welcome ESA Director General Joseph Ashbacher. Dr. Ashbacher, please call station for a voice check.
Station, this is Joseph Ashbacher. How do you hear me?
Hey, Joseph, we hear you loud and clear. Welcome to the space station.
Thank you, Thomas. This is really great to see you, that you and your crewmates have arrived safely on the space station. Greetings to all of you, 11 of you at the station from all of us at ESA. It is really a fantastic effort to see you all so nicely grouped together in the group photo. I think the station needs expansion, seeing that you're all crowding together so nicely. On ESA, Thomas, we are all very, very proud of you and what you're doing for space, for Europe, for the Space Agency, also for France. You're extremely popular, as you know. We're all very proud of you, but of course we're also very proud of all the other colleagues which are next to you, because astronauts are so fascinating and they give so much inspiration to all of us. So this was the first launch of an ESA astronaut on a Crew Dragon. It was spectacular, and together with Philippe Baptiste, the newly elected CNES president, we have followed very closely from the suits up all the way to the orbital journey to the station, and now just recently, just a few minutes ago, the hatch opening, and this was really so exciting and really fantastic. It has been, I think, a long day for all of you, but you all look extremely in good shape and in good spirits. You're all smiling. This is really fantastic to see down here from Earth. But ESA is really very happy to see your assignment, Thomas, towards the end of the mission as the ISS commander. And I really would like to take this opportunity to thank the partners of the space station for this honor to give to Thomas, which certainly is a sign and a recognition of his quality and also his personal quality, but of course engineering and technical qualities to be the commander of the station, and also recognition for ESA as being a strong partner and supporter of the space station all the way. So I know that you have a long and very intense training period behind you, and you're all set to go. There's a lot ahead of you. Hundreds of experiments are waiting, and all of you will be kept extremely busy, but we all look forward to see the results of these experiments. So Thomas, really very best wishes from all of us. Good luck and bonne chance.
Hey, thanks, Joseph. It's really unbelievable to be here on Space Station. Space Station has changed quite a bit since last time I was here. I've never seen so many astronauts on board. I've never seen so many different spacecrafts on board, and I think it's a tribute to how strong the program is going. I want to echo what Megan has said. It took a lot of effort from all kinds of people, you know, from the highest manager to all kinds of support persons to bring us here. So we want to thank all of them. And I want to say a few words about international cooperation. You said a lot, but it's been 20 years since it's been 20 years. Actually, Shane's line, I learned it from Shane. It's 20 years since JAXA and ESA and NASA and Russian astronaut have been together in space. So it's actually pretty historic what's happening today. We can't wait to start our work on the space station. We can't wait to see what's ahead on the adventure for us. In those 5 months, we're so happy to see our friends. We're going to have to say goodbye to them soon. We wish we could keep them a little bit longer, but not too long as well, because 11 people is a lot on space station. But yeah, it's good to be here. Really, we're impatient, and it's going to be unbelievable. I want to say a few words in French. Je voudrais surtout remercier tous les gens qui ont travaillé sur cette mission en français, et puis un petit mot pour les familles et les amis qui sont déplacés jusqu'à Cap Canaveral. Ça n'a pas été un voyage facile. En tout cas, ça m'a vraiment fait chaud au cœur de les avoir avec moi. Donc je voulais les saluer un peu particulièrement. Voilà. Merci à tous.
All right, go ahead and...
Station, this is Houston ACR. That concludes the event. Thank you.
Thank you, Acting Administrator Jersic, Associate Administrator Leaders, Dr. Yamakawa, and Dr. Aschbacher for your participation in the Crew-2 welcome ceremony. Station, we are now resuming operational audio communications.
Wow, what an incredible morning, Gary. It is so cool to see the Crew-2 crew on board with the rest of the astronauts on the International Space Station.
That's right. They were welcomed by leaders from each of the space agencies that represent the cadre that is the Crew-2 astronauts aboard Crew Dragon Endeavour. We first heard from Steve Jerzik, who's the acting administrator of NASA, based at NASA headquarters. We also then heard from Kathy Leaders, who's the associate administrator for Human Exploration and Operations Mission Directorate at NASA headquarters. Then we got to hear from the president of the Japan Aerospace Exploration Agency, Hiroshi Yamakawa, and Joseph Aschbacher wrapping up the comments as the Director General from the European Space Agency, each of them chiming in and talking about just what it took to get to this moment with 4 astronauts on board, 4 additional astronauts on board, I should say. An 11-person crew now makes up Expedition 65.
Yeah, it's been an incredible 24-plus hours for this Crew-2 mission. This was NASA's SpaceX Crew-2 mission, and we have been with you all from the beginning, starting up with suit-up of the astronauts in the suit-up room at the ONC building, following the crew on the NASA Causeway in their Teslas as they made their way to the launch pad, go up the fixed service structure and ingressed on Crew Dragon Endeavour. We had an on-time liftoff yesterday morning at 5:49 a.m. Eastern Time, with the first stage separating and coming back to Earth for its second flight and second landing on, of course, I Still Love You, while Dragon, separated from second stage, had a good nose cone deploy. We had 5 major burns on Dragon as it made its way to the International Space Station, and finally docking to the space station, where we just a few moments ago watched the crew ingress onto the International Space Station. So an incredible past day watching this mission. On behalf of SpaceX and NASA, thank you for watching today's webcast and for your interest in this exciting second rotational crew mission. Now that Dragon Endeavour has reached the International Space Station, it will spend approximately 6 months docked there until it's time for Crew-2 to return home via a splashdown in the Atlantic Ocean.
And now that Crew-2 has arrived, we're less than a week away from the return of Crew-1. We'll be taking you along as Mike Hopkins, Victor Glover, Shannon Walker, and Soichi Noguchi return home after their long-duration stay aboard the station. They're currently targeted to return on Wednesday, April 28th, so be sure to tune in as NASA and SpaceX bring you live coverage of every step of their journey. Be sure to follow NASA and SpaceX on social media for real-time updates. And thanks again for watching our coverage. Go NASA, go SpaceX, and go Crew-2. We'll see you again real soon.